character under the study. Okay.
Doctor, the slides are not moving.
Okay.
Yeah, you can go full screen also. Yeah.
Hello.
Yes, doctor.
Yeah, how's the participants? So please enable this screen sharing.
Yeah, yeah.
Yeah. Slide was not moving.
Yes, doctor.
So is there any setting? Because I have shared that whole PPT.
You can now start sharing.
Now whether it is moving?
It's in the second slide.
Okay, now it is moving.
No, doctor.
So which option is there?
Sir, please make full screen.
Yeah, madam, it is already full screen.
But it is not showing full screen. Sir, you can stop sharing and again reshare.
Yeah. Still it is same problem.
Sir, can you share the PPT to us so that we will share from our end?
No.
What?
No. Just reshare. You try to reshare, doctor. Close
Yes,
this and then again once again try.
Yes.
Yeah, now it is moving.
Okay.
Yes.
Yeah, okay.
Okay.
Okay, sorry. So certain terminology that you know very well. So sample, parameter, then variable. So that is a character that under study which vary from individual to individual or time to time. Then variate. So whatever the data you have measured, that is called as a variate. Then as I told, this variable that may be quantitative variable, qualitative variable. So this quantitative variable, they may be of discrete variable and also continuous variable. So for example, in the number of students in the class, number of the different trees in the forest. So all are, we can say they are discrete because they are taking the whole number. And continuous variable, so when it take any value, okay, within a range. So like the distance, what we can say volume, or we can say body weight. So body weight take any value, so we can say it is a continuous variable. Now, as for the statistic, the first step, that is the collection of the data. So definitely the collection of the data, it is by the process of counting. I think slide is moving.
Yes, doctor.
Okay. So the process of counting or measurement, that is, we can say a collection, and the data, it may be of primary data, it may be of secondary data. So primary data, that is the, we can say it is originally collected by the investigator himself or herself. So first time, so we can say it is a primary data, and secondary data, that is the data which have already collected and it is used by some other person, that is the secondary data. Okay, for example, if you are doing your investigation and during the investigation you are collecting the data, so we can say it is a primary data. But if someone, for example, a government has conducted the survey or census, okay, population census, and if you use that population census data, then it will become a secondary data for you. For example, newspaper data, periodical, magazine, scientific journal, book, all are secondary data for you. Okay, but if you collect your own first time, then it will be the primary data for you. So descriptive statistics. So descriptive statistic, that is, we can say that is used to describe the basic features of the data in the study. Okay. So first part, that is the first part of the analysis in the biostatistic, that is a descriptive statistic. And if you have a simple data, you can simply find out the different mean, median, mode, range, standard deviation, standard error, CV%, etc. You can find out. So this all the component, they are called as a descriptive statistic. So it will give the idea about the what is actually present in your data. Okay. So this descriptive statistic can be done in the simple Excel also. Okay. In Excel, this descriptive statistic analysis option is there. Okay. And in the MS Excel, you will find the mean, median, standard deviation, all the descriptive statistic. Okay. So within a single click. Okay. So this you can use this Excel for getting the descriptive statistic. You can use this certain license software also, freely available web packages for the getting the descriptive statistic. Because the first step is to get the descriptive data. Okay, because if you conduct your experiment, you will get some data. So okay, so whether this data they are in the appropriate range, whether they have a appropriate mean, so that can be seen by simply descriptive statistic. Now let's move on the this test of significance. So it is very important in the research aspect. Okay, so I have skipped that normal distribution, then probability, because it is not much useful for your research data analysis. So I will focus only those topics which are very important. So test of significance, it is very important topic that is useful, we can say, for the analysis of your data. So test of significance, what is actually test of significance? So it is a statistical procedure to decide whether the observed difference between the sample mean and population mean or some hypothetical mean, is it real or not? So the simple definition, or we can say explanation, that is, it is a procedure to decide the observed difference. अगर मान लो कि आपके पास दो वैरायटी है, दोनों में डिफरेंस है, एक का मीन है 10, दूसरे का मीन है 20. Okay, so yes, definitely there is a variation in the data. Okay, but is it significant? Is it real data, or by we can say by chance? Okay, so for testing that, we have to use this test of significance. So this test of significance that include the various tests like the parametric test and non-parametric test. So parametric tests that rely on the statistical distribution in the data. So it is based on here for the parametric test, we are assuming that our data, they are following the normal distribution. So this parametric test that include that the T test, pair T test, Z test, F test. Okay, and in case of non-parametric test, it does not require any population distribution, and which meant by the distinct parameter. So example, that is the chi-square test and Pushkal-Wallis test and Mann-Whitney test. So these are the non-parametric tests. They are sometime occasionally we have to use this non-parametric test. It depends on your study, it depends on your data. Okay, so but generally we are using this parametric test. Okay. So let us see what is actually this T test, pair T test, Z test, F test. So you might be aware about this test of significance. So I will focus about all the test of significance with some example if possible. So here test of significance for large sample. So definitely it is a Z test. So we can say if the sample size it is greater than 30, so we can take this consider as a large sample, and for that we have to perform the Z test. So following are the main three use of the Z test to compare the sample mean with the population mean, and to compare the sample mean with when the population variance is given and sample size is large, and to compare the sample mean with the population variance. So it is very difficult, okay, difficult to understand, okay. But in simple language, you remember that if the sample size it is greater than 30, you can go with the Z test, okay, if the population standard deviation is known, okay. So slide is not, yes. Here it is one example is there. So here in example, two ration are there, A and B ration are there. A and B ration are there, and we have to compare which ration if we fed to the animal will give the more milk yield. अगर हमारे पास दो राशन है, हम दोनों वो दो राशन एनिमल को खिलाते हैं, तो किस में मिल्क यील्ड ज्यादा देगा, ओके, किस में कम देगा, that we have to determine. So here you can see the ration A. So when we fed this animal with the ration A, it will give the 5.2 kg average milk yield. And if we fed this ration B, it will give the 6.5 kg, okay, per day. So definitely there is some difference. Yeah, आप देख सकते हैं कि यहाँ पे 6.50 है, यहाँ पे 5. So definitely it is. Hello. So यहाँ पे आप देख सकते हैं कि there is obviously it is a 1.3 difference is there. So here the difference is there, but whether this difference it is a real or not, that we have to we can say that on the basis of Z test. तो यहाँ पे सैंपल वेरिएंस दिया है और यहाँ पे साइज सैंपल साइज यहाँ पे देख सकते हैं कि 40 है. So definitely if it is a sample size it is for more than 30, so we will go with the Z test. And this is the formula and this is the calculation part. It is not we can say we have not sufficient time to discuss this calculation part, so you can understand from this slide also. So once you calculate this Z test, this is the formula for the calculation of the Z test, you will get the calculated Z value. So if you compare this calculated Z value with the table value, you can compare this calculated Z value with the table value, and on the basis of you can say that yes, it is a significant. So यहाँ पे table value 1.96 है, यहाँ पे calculated table value आ गया, calculated T value Z value आ गया 10.56. So definitely the calculated Z value is greater than the table value. So we can say we have to reject the null hypothesis and we have to accept the alternative hypothesis. And once the test is significant, now we can say yes, definitely if we fed the animal with the ration B, it will give the more milk as compared to the ration A. So यहाँ पे हमें अगर strongly बोलना है, मतलब we have to give the some recommendation to the farmer or anyone. Okay, आपको strongly बोलना है कि भाई yes, आपको ये खिलाना चाहिए, तो इसीलिए आपको टेस्ट ऑफ सिग्निफिकेंस में जाना पड़ेगा. मतलब आपको सिग्निफिकेंट के लिए सिर्फ एक वर्ड के लिए आपको ये टेस्ट ऑफ सिग्निफिकेंस जाना पड़ेगा. ओनली द वर्ड इट इज अ सिग्निफिकेंस. आप यहाँ पे भी बोल सकते हैं कि भाई यहाँ पे राशन बी खिला दो, कोई बात नहीं, उससे भी ज्यादा मिल्क देगा, ओके, लेकिन सिग्निफिकेंट देगा या नहीं देगा, ओके. सो दैट फॉर दैट पर्पस वी हैव टू गो विद द टेस्ट ऑफ सिग्निफिकेंस. नाउ किसी को भी लगेगा कि भाई इसमें भी क्या है, ये ओनली द डिफरेंस इट इज 1 लीटर, लेस देन 1 लीटर डिफरेंस है, तो क्या फर्क पड़ता है, ओके. सो सपोज फर्क यहाँ पड़ता है कि सपोज सो यहाँ पे मान लो कि राशन ए है, तो राशन ई का कॉस्ट है मान लो कि 50 रुपीज पर केजी, ओके, 50 रुपीज पर केजी है भाव उसका, और राशन बी का है मान लो कि उसका 51 केजी, ओके, 50 रुपीज पर 1 केजी. तो यहाँ पे आप देख सकते हैं दोनों का कॉस्ट ऑलमोस्ट इक्वल है, ये फायदेमंद है. सो वी कैन से दैट यस राशन बी इज एप्रोप्रिएट, ओके. अगर मान लो कि आपका नॉन सिग्निफिकेंट रिजल्ट आता, अगर नॉन सिग्निफिकेंट रिजल्ट आता, राशन ए का प्राइस है 50 रुपीज पर केजी और इसका मान लो कि 60 रुपीज पर केजी है, अब दोनों में कोई डिफरेंस नहीं है, तो आप कौन सा सजेस्ट करेंगे? जो चीपर होगा वही सजेस्ट करेंगे, मतलब यू विल सजेस्ट दिस राशन ए. ओके, so you will definitely suggest that you will go with the ration A instead of the ration B. So for that significant word के लिए हमें ये टेस्ट तो लगाना पड़ेगा. So another test, that is the, we can say this test of hypothesis for small sample. यहाँ पे small sample के लिए, so it is a T test. Okay, so when the sample size it is a less than 30, we can say it is a small sample size. So here we can use this comparison of the sample mean with the population mean, that is the student T test. आपने कहीं नाम भी सुना होगा. Comparison of the two sample mean from the two independent samples, that is the Fischer T test. And when the testing the significant mean difference in case of pair observation, it is a pair T test. So here same ration A and ration B है. यहाँ पे सिर्फ only the difference it is the sample size. आप देख सकते हैं कि यहाँ पे sample size कम है, 30 से कम है. So definitely we will go with the T test. Okay. So here we will perform the independent sample T test. So these are the formula, and for that we have to find out the pooled variance. Pooled variance, that means we have two different ration A and ration B. So we have to find out the pooled variance, common variance. And once we calculate this calculated T value, we have to compare with the table value. And on the basis of comparison of this table value with this calculated value with the table value, here आप देख सकते हैं कि भाई table value है, it is a 7.4 है, and the table value it is a 2.03. So here calculated T value it is greater than the table value, so we can say it is a significant difference between the ration and B. So on the basis of that, we can conclude that the feeding of ration ration B will cause them to give the more milk than the feeding of the ration A. So यहाँ पे भी आप बोल सकते हैं कि अगर मान लो कि नॉन सिग्निफिकेंट आता तो आप बोल सकते हैं कि yes, either you can feed this ration A or B, it doesn't affect the milking okay much. Obviously the ऑब्जर्वेशन में देखोगे तो डिफरेंस है, लेकिन अगर नॉन सिग्निफिकेंट आया तो यू कैन से दैट यस, आप चाहे राशन ए खिला दो राशन बी खिला दो, कुछ ज्यादा फर्क नहीं पड़ेगा. ओके, लेकिन सिग्निफिकेंटली डिफरेंस देखना है तो डेफिनेटली यू हैव टू गो विद दिस टेस्ट ऑफ सिग्निफिकेंस, और सिग्निफिकेंट आना चाहिए. तो यहाँ पे वी हैव गॉट दिस टेस्ट ऑफ सिग्निफिकेंस, इट इज सिग्निफिकेंट, सो वी कैन से yes, definitely if we feed the ration B, it will give the more milk. Okay, so this is the independent sample T test. Now another, that is the pair T test. So sometime whenever you are belonging to the some medical science or like that, okay, and if you are doing the experiment and if you have a pair observation, so pair observation, that means whenever you are taking the animal or whatever the patient, okay, or if you have suppose 10 animals are there, okay, if you want to test the effect of paracetamol in the fever, so what to do? So first you take the temperature, okay, then you will give the paracetamol to each and every animal, okay, and after giving the paracetamol, again you are taking the temperature, okay. So you have a two observation, pair observation. हर एक एनिमल के आपके पास दो ऑब्जर्वेशन होंगे, before treatment, matlab before giving the paracetamol and after giving the paracetamol. So here each and every individual have pair observation. So in that condition we have to use the pair T test. Okay, so the effect of example, it is the effect of treatment is tested on the milk yield on the dairy cow, and the milk yield were measured before and after the administration of the treatment. तो हमें चेक करना है कि सपोज पैरासीटामोल की बात करें तो वी हैव टू चेक वेदर दिस पैरासीटामोल इट इज इफेक्टिव इन द ट्रीटमेंट ऑफ द फीवर और नॉट. ओके, तो इसीलिए आपको दो डेटा चाहिए, बिफोर एंड आफ्टर डेटा चाहिए. ओके, सो लेट अस सी द एग्जांपल. ओके, ये काउ है, नंबर ऑफ काउस 9 डिफरेंट काउस आर देयर, एंड हियर द ट्रीटमेंट मतलब ट्रीटमेंट वी हैव allotted. And before the treatment allocation, we have taking the observation. So it is a, we can see it is a before treatment. So here these are the before treatment. Okay. And after the admission of the treatment, So in case of that is called as a pair t test. Okay, अगर आपके पास एक ही एनिमल के एक ही इंडिविजुअल के दो ऑब्जर्वेशन है बिफोर एंड आफ्टर, so we can say that it is a pair t test. So we have to perform the pair t test, and for that we have to find out the difference and difference pair. So this is the formula for the standard deviation, and this is the final formula for the pair t test calculated t value. So it is a d bar. So whatever the difference, and you have to find out the average. So it is a 3.1. So यहाँ पे d bar आएगा -0 आएगा, standard deviation divided by square root of n. So here calculated t value, it is a 2.61. That we have to compare with the table value. यहाँ पे हमारे पास 9 एनिमल थे, so 9 - 1, so it is a 8 degree freedom. Okay. So here we have to compare this calculated t value with the table value. So definitely here it is a calculated t value. It is greater than, less than table value. So we can say, here the calculated value, it is greater than table value. यहाँ पे ये calculated value है, ये table value है. So it is more than table value. So we can say yes, definitely the test is significant and the treatment does influence the milk yield. Now non-parametric tests that include the chi-square test. अगर आपके पास कुछ ऐसे डेटा हो सकते हैं जिसमें you cannot able to follow this parametric test. So in that condition you have to go with the non-parametric test, especially it is a chi-square test. So chi-square test, it is, we can say, non-parametric test, and it was given by the Carl Pearson. And it is the most prominent non-parametric test, and it describes what is the use of that chi-square. So it describes the magnitude of discrepancy between the theoretical and observed frequency. So अगर आपके पास observed frequency है and you have to expected frequency, then whether the observed frequency or expected frequency में you can say discrepancy है या नहीं, that can be determined by the this chi-square test. So it is a O minus E whole square divided by E. So whenever your data in the form of some ratio, in the form of some count, okay, in that condition you can know to go with the this parametric test. You have to go with the this non-parametric test. मान लो कि आपने देखा होगा मेंडल को नाम सुना होगा. So मेंडल को उसने स्टडी किया तो उसको फर्स्ट जनरेशन में मतलब 3:1 रेशियो मिला था, डायहाइब्रिड में 9:3:3:1 रेशियो मिला था. So likewise, whenever you want to compare your data, आपको भी अपने डेटा मतलब कोई रिसर्च किया, उसमें आपको रेशियो मिला, मान लो कि 2.5:1 मिला रेशियो, किसी को मिला similar to 9:3:3 likewise. So if you want to compare this obtained ratio with the expected ratio, so definitely you have to go with the chi-square test. So mainly this two application of the chi-square. So it is to test the goodness of the fit of observed data. So whether this observed data, they are matching with the expected one or not, and to test the independence of the attributes. For independence of attribute, like for example, your two attributes, like the example, it is a COVID vaccination and corona positive. Okay, so here two attributes are there. Whether this corona vaccine, co-vaccine, मान लो कि co-vaccine it is effective in the treatment of the COVID-19 or not. So the here COVID positive and negative, this is the one attribute, and another, that is the vaccination and non-vaccination, it is another attribute. So on the basis of that we can, अगर आप उसमें क्या लेंगे, उसमें आप डेटा लेंगे कि भाई जिसको वैक्सीनेशन किया है उनको कितने लोग हैं उनको कोविड पॉजिटिव आया, जिनको वैक्सीनेशन नहीं दिया उसमें से कितने कोविड नेगेटिव आए, जिनको वैक्सीनेशन नहीं दिया था उसमें से कितने कोविड पॉजिटिव आए, और जिनको वैक्सीन नहीं दिया था उनको उनमें से कितने कोविड नेगेटिव आए. So for that comparison, whether this vaccine, co-vaccine, is effective in controlling the this COVID-19 or not, so that can be checked or evaluated by this chi-square test. So chi-square test, it is only when your data in the form of simply count. Okay, जैसे मैंने बताया ना कि अपने you are giving the co-vaccine. Okay, तो कोवैक्सीन दिया है और कोविड पॉजिटिव आए ऐसे इंडिविजुअल कितने, सो इट इज सिंपली व्हाट, इट इज अ काउंट, okay? It is not a measurement. So such type of the data, in that we can go with the chi-square test. Okay. Now let's move on the actual topic, that is the experimental design. Okay. So it is very important. It is a research aspect. Okay. So whenever you do the research, so definitely two statistical, we can say, tool that can be useful for you. One is the test of significance. So either you will use the test of significance. So test of significance आप कब use करेंगे? When you will use the test of significance. So test of significance, it will be useful when you have only the two treatment. आपके पास दो treatment है. आपके पास दो treatment है. So you have two different treatments are there. Okay, then you can use that T test. Okay, T test, Z test आप कर सकते हैं. But if it is more than two treatments are there, in that condition you cannot go with the T test. Yes, definitely you can go. Okay, so suppose you have three different treatment A, B, C. So you can go with the A, B, B, C, and AC. This T test, okay, but whenever your number of treatment will be more, it is very difficult to go with the T test. Okay, so whenever, please remember this thing, whenever you have three different treatment or more than two different treatment, you have to go with the ANOVA, or we can say experimental design. So what is actually experimental design? So certain, before going to the experimental design, certain terminology that is you have to understand that experiment, so it is a plan investigation. Okay, so definitely you, before going to the experiment, you will do some plan. Okay, so that is the experiment, or we can say it is a study, trial, or whatever. Experimental design, so it is of simply planning. Okay, आप you will do the plan. Yes, मैं इसमें इतने एनिमल लूंगा, इसमें इतने ये ट्रीटमेंट दूंगा, ये होगा. So layout, you will understand the methodology. So all are under the experimental design. The treatment, so any condition that is applied to the experimental unit. So experimental unit क्या है? So what is experimental unit? So experimental unit, that means you can take the lab animal, you can take the large animal, you can take the agriculture land. So all are considered as a experimental material. Okay, so treatment, that is it refers to the condition that is applied to the experimental unit. Okay, or it can be form of the it is not कभी कई लोगों को ऐसा लगता है कि ट्रीटमेंट वर्ड आता है एक्सपेरिमेंटल डिजाइन में, सो इट इज ओनली इंजेक्टेबल. So treatment, that means it is not only the injectable, it is any condition. आप फीड खिलाते हैं तो भी वो ट्रीटमेंट हो गया. आप you are providing the different temperature, so it is also, we can say, consider as a treatment. तो आप कोई भी कंडीशन प्रोवाइड करते हैं, कोई ग्रुप बनाते हैं, कोई कैटेगरी करते हैं, so they are considered as a treatment. So example of this application of the feed to the animal, application of the fertilizer to the agriculture plot. So this fertilizer is a treatment. Okay. Then experimental unit. So it is we can say smallest unit of the experimental material to which the treatment is applied. Then uniformity trial. So when we apply the similar kind of the treatment to the all the experimental material, so it is called as a uniform. एक्सपेरिमेंटल मटेरियल मैंने बोला कि वो एनिमल भी हो सकता है, प्लांट मतलब प्लांट भी हो सकता है, कोई लिविंग नॉन लिविंग थिंग भी हो सकता है. ओके, बट उसमें से मान लो कि आपके पास 1000 एनिमल, तो 1000 एनिमल, 1000 cow, they are considered as experimental material, but you will not take all the animals for your experimental purpose. So you will take the hardly 20 animals. So that is the experimental unit. In experimental error, so definitely you will get some variation, unit to unit variation within the same treatment group. So that is called as a एक्सपेरिमेंटल एरर। मान लो कि आपने 10 एनिमल सिमिलर टाइप के लिए है, इवन दो देयर इज सम डिफरेंस इन द मिल्क yield, so whatever the difference in the milk yield, that is the, we can say, experimental error. Then layout and purpose of the experiment. So purpose is to obtain the valid conclusion, okay, and to estimate the error component or experimental error, and to for the generalization of the experimental result. तो अगर कुछ भी आपको कंक्लूजन देना है, कुछ भी रिकमेंडेशन देना है कि ये 3-4 ट्रीटमेंट में से ये ट्रीटमेंट अच्छी है, then you have to go with the experimental design. So mainly the principle of this experimental design, it is working on the mainly 3 principles, that is the replication, randomization, and local control. So replication, that is the principle, first principle, and name itself indicate it is the repetition of the basic treatment under. तो आप कोई भी एक्सपेरिमेंट करते हैं, suppose here you can see this is my treatment, these are the hormonal therapy, okay. If I am giving the same PG-up2 alpha hormone to the 5 different animals, okay, here FSH hormone, it is also giving the 5 animals. So this is what R1, R2, R3, R4, it is, we can say, replication. So I am repeating the same treatment to the different animal, okay, repetition. So replication, that means it is the repetition of the treatment into the different experimental unit. तो यहाँ पे मेरी रेप्लिकेशन क्या हो जाएगी, 5 5 5 5 रेप्लिकेशन. तो यहाँ पे इक्वल नंबर ऑफ रेप्लिकेशन है, सो वी कैन से इट इज अ इक्वी रेप्लिकेटेड डिजाइन. यहाँ पे यू कैन सी हियर आई एम रेप्लिकेटेड दिस PG-up2 alpha into the 4 animal, FSH into the 6 animal, LH into 3 animal, and progesterone into the 5 animals. So we can say here the replication, it is unequal. So we can say it is an unequal replicated design. Second principle, that is the randomization. So name itself indicate randomization. That means whatever the treatment we have to allot to the experimental unit, it should be randomly without any bias, okay. So that is the randomization. And third principle, that is the local control. So local control, that is the control to control the inherent variation or natural variation. For example, मान लो कि आपने कोई एक्सपेरिमेंट शुरू किया, आपने एनिमल ले लिया, एक्सपेरिमेंटल एनिमल ले लिया, ओके. अब मान लो कि एक्सपेरिमेंटल एनिमल तो ले लिया, उसमें देयर आर टू मच वेरिएशन. किसी का बॉडी वेट 800 kg है, किसी का बॉडी वेट 200 kg है, किसी का 500 है. So here there is too much variation in the we can say data, okay, too much variation in the this experimental material. So in that condition, we cannot go with directly only basis of replication and randomization. We have to go with the third principle, that is the local control. तो लोकल कंट्रोल में हम क्या करते हैं, वी आर ट्राइंग टू रिड्यूस द एक्सपेरिमेंटल एरर. तो कैसे करेंगे हम, तो हम होमोजीनियस ग्रुप बनाएंगे. मतलब मान लो कि भाई 400 किलो से कम वेट वाले एनिमल कितने हैं, उनको एक ग्रुप में डाल दो. 400 से 600 वाले एक ग्रुप में डाल दो. 600 से 800 वाले एक ग्रुप में डाल दो. 800 से ज्यादा वाले एक ग्रुप में डाल दो. So whatever we are making the group, that is, we can say it is the local control, okay. So the purpose of this local control is to reduce the experimental error and to get the accurate treatment effect. So यहाँ पे जैसे यहाँ पे आप देख सकते हैं different age group और different body weight वाले animal है. तो I have divided into the different block. So this blocking, that is called as a, we can say it is the third principle, local control. Now analysis of variance. So ANOVA, it is very important. The ANOVA that contain the source of variation, component of variation. Okay. So what is ANOVA? So it is, we can say it is a splitting of this total variation into the various component. Okay. So I will not go line by line. Okay. So this is the step to calculate the ANOVA. So first you have to find out the grand total, this correction factor, total sum of square. Let us see the one example. So this is, we can say, layout of the ANOVA. ये ANOVA है. तो यहाँ पे here you can say between treatment, within a treatment, or you can say total. तो यहाँ पे source of variation कितने हैं? So here it is the between treatment, within treatment, and total. यहाँ पे degree of freedom है, sum of square है, that you can find out using this formula. Then it is the mean sum of square. So this, whatever the mean sum of square, it is considered as a variance, and F test, it is the ratio of the two variance components. So it is the between the treatment group divided by error, or within a group, within treatment group. If you compare, if you calculate this F value, you have to compare with the table value, and on the basis of that table value, you can say, yes, there is a significant difference between the treatment. So let us see first experimental design, and most important, that is the CRD, completed randomized design. So यहाँ पे complete randomized design, when we use this this CRD. So CRD, it is applicable when your experimental material, they are homogeneous. So as I shown the picture, here you can see all the animals, they are looking the similar. Okay, आप देख लो body structure में भी देख लो, body height में भी देख लो, all are animal, they are looking the similar. So we can say yes, our experimental material is homogeneous. जैसे मैंने बताया कि आप 10 एनिमल ले रहे हैं और 10 एनिमल का मान लो कि बॉडी वेट नियर अबाउट द 650 है. So we can say yes, all animal, they are of the same body weight, so we can say it is a homogeneous experimental material. So if it is a homogeneous experimental material is there, we have to use this replication and randomization process, or we have to follow this CRD, completely randomized design. यहाँ पे third principle की जरूरत नहीं है. Why we are not using this local control? Because here our experimental material, it is already similar, okay, already homogeneous. So no need to make the block, okay. तो यहाँ पे local control का कोई role नहीं है. तो यहाँ पे हम दो ही प्रिंसिपल अप्लाई करेंगे, रेप्लिकेशन एंड रैंडमाइजेशन. So what are the use of this CRD? So CRD, that is used in the laboratory study, or we can say experiment in the laboratory animal, pig, and sheep, where the experimental material, they are homogeneously available. So everywhere, okay, everywhere, कहीं पे भी आप देख लो तो CRD तो common ही use होता है. CRD होता है, T test होता है, depends on the number of treatment. If you are comparing the 4 different treatments, so more than 2 different treatments, so you will go with the CRD or RBD or whatever it may be. And if it is less than 2, then it is a T test. So here we can see this is the skeletal Anova of the CRD. So CRD में between treatment आएगा, within treatment आएगा, और total आएगा, okay, and sum of square आएगा, then mean sum of square, and the comparison or ratio of this between the treatment and within treatment group, that is called as a calculated F value, that we have to compare with the table value. Advantage of CRD, so it is, you can say, it is very simple layout, and it is the most flexible design. Okay, any number of treatment you can take. आप ऐसा नहीं है कि भाई 4 ट्रीटमेंट ही ले सकते हैं. आपको मान लो कि 5-6 ड्रग कंपेयर करनी है, मान लो कि 10 वैक्सीन आपको कंपेयर करनी है, then you can take this CRD. Okay, so any number of treatment you can take here in case of CRD. And even though मान लो कि आप एक्सपेरिमेंट कर रहे हैं, during that experiment मान लो कि suppose you have taken this 6 animal, आपने मान लो कि हर एक में 6 एनिमल लिए हैं. ओके, मान लो कि पहला ट्रीटमेंट ग्रुप है, उसमें 6 एनिमल लिए, दूसरे में 6, तीसरे में 6, सभी में 6 एनिमल लिए. मान लो कि ड्यूरिंग द एक्सपेरिमेंट कोई एनिमल मर गया. ओके, तो यहाँ पे कौन सा क्या बचेगा? 5 एनिमल बचेगा, किसी में 4 बचेगा. सो दैट इज कॉल्ड एज अ मिसिंग ऑब्जर्वेशन. तो CRD दैट कैन बी एप्लीकेबल इन द मिसिंग ऑब्जर्वेशन. And the CRD that provide the maximum degree of freedom, so we can say that compared with the compared to the other design. So we can say, and this is very important, आपको रिपीटेशन और रेप्लिकेशन ऐसे रखना है कि मिनिमम एरर डिग्री ऑफ फ्रीडम इट शुड बी मिनिमम 12. तो यहाँ पे मैंने जैसे बताया कि मिनिमम एरर डिग्री ऑफ फ्रीडम यहाँ पे, सो यहाँ पे एरर डिग्री ऑफ फ्रीडम जो यहाँ पे जो वैल्यू आएगी वो मिनिमम 12 होनी चाहिए, देन ओनली इट विल बी द वैलिड वी कैन से एक्सपेरिमेंटल डिजाइन. तो कब वो 12 बनेगी? सो व्हेन एवर यू टेक द 6 रेप्लिकेशन. ओके, जैसे मैंने बताया कि हर एक ट्रीटमेंट का आप 6 रेप्लिकेशन लेंगे, देन ओनली यू विल गेट. यहाँ पे मैंने 5 लिया तो यहाँ पे शायद 12 डिग्री ऑफ फ्रीडम, 12 एरर डिग्री ऑफ फ्रीडम हो जाएगा. लेकिन बेटर टू गो विद दी 6 रेप्लिकेशन. तो आप देखोगे तो ज्यादातर कोई स्टडी होता है उसमें 6 रेप्लिकेशन होते हैं, 6 एनिमल होते हैं. इन आवर वेटनरी साइंस वी आर टेकिंग द मिनिमम 6 नंबर ऑफ एनिमल्स. ओके, बिकॉज yes, definitely we are trying to take the more and more animal because of the ethics committee. We have some limitation and we have to take only the 6 animal. अगर ethical committee नहीं होती तो definitely we will go with the 12 or 20 animals. Okay, So there is no any we can say limit restriction in the agriculture. Okay, they can take the any number of replication. तो उनको कोई ये एथिक्स नहीं है, तो वो कई सारे रेप्लिकेशन लेते हैं. So as you increase the replication, your experiment will be more and more accurate. Okay. A disadvantage is, so disadvantage that is they are not much more. Okay. So here मोस्ट इम्पोर्टेंट डिसएडवांटेज कि भाई अगर आपका एक्सपेरिमेंटल मटेरियल हेट्रोजीनियस है तो आप ये सीआरडी नहीं कर सकते. सो हियर यू कैन सी दिस इज द, मेरे पास 5 डिफरेंट फीड है, तो डेफिनेटली 2 से ज्यादा है. ओके, तो यू कैन सी हियर द फीड नंबर 1, सो कितने रेप्लिकेशन है, 4 रेप्लिकेशन. फीड 2 की 4 रेप्लिकेशन, हर एक फीड की 4 रेप्लिकेशन है. सो नाउ आई वांट टू टेस्ट ये 5 फीड में से कौन सा फीड बेस्ट है. ओके, तो ऑन द बेसिस ऑफ मीन वैल्यू से पता चल जाता है कि भाई फीड 3 इट इज द बेस्ट एज कंपेयर टू द अदर फीड, और सबसे पुअर फीड कौन सा है कि भाई फीड 1 है. लेकिन if you want to prove statistically then you have to apply this design. तो यहाँ पे 2 से ज्यादा ट्रीटमेंट ग्रुप है, तो I will go with the design. तो यहाँ पे स्टेप बाय स्टेप करेक्शन फैक्टर निकालना है आपको, तो उसके लिए ग्रांड टोटल स्क्वायर करना है, डिवाइडेड बाय n करना है, टोटल सम ऑफ स्क्वायर निकालना है. ये सभी वैल्यू आपको निकालना है. You try to understand from the PPT, and here this is the calculated F value and this is the table value. So here we can say calculated F value is greater than the table value. So we can say that yes, definitely there is a significant difference between the different feed. अब वो सभी feed में difference है, लेकिन वो सब में कौन से feed में difference है, that can be understand by the CD value. That is the critical difference. So this is a comparison. Okay, तो on the basis of finally we can say 8 on no mean वाले, मतलब जो जिसका मीन F1 था, मतलब जो फीड F1 एंड F5 था वो दोनों में नॉन सिग्निफिकेंट है. मतलब चाहे आप फीड 1 खिला लो या फीड 5 खिला लो, दोनों में कोई डिफरेंस नहीं है. सिमिलरली आप चाहे फीड 5 खिला लो या फिर फीड 2 खिला लो, कोई डिफरेंस नहीं है. सिमिलरली आप चाहे फीड 2 खिला दो या फीड 4 खिला दो, दोनों में कोई डिफरेंस नहीं है. एंड ओनली द फीड 3 it is a significantly difference. Okay, so ऐसे हम कंक्लूड कर सकते हैं. तो जो भी आपने कोई आर्टिकल देखा होगा तो उसमें सुपरस्क्रिप्ट रखते हैं. तो सुपरस्क्रिप्ट कैसे रखते हैं, तो ऑन द बेसिस ऑफ दिस CD वैल्यू. ओके, सो हियर द CD वैल्यू, सो वी हैव टू कंपेयर ऑन द बेसिस ऑफ CD वैल्यू वी कैन पुट द सुपरस्क्रिप्ट. Now what this superscript indicates, so this sentence that indicate the meaning of the superscript. So it means the mean with a different superscript. तो जहाँ पे ये mean लिखा है उस पे superscript अलग है, different superscript they are differ significantly. तो यहाँ पे आप देख सकते हैं, यहाँ पे superscript A है, यहाँ पे A है, तो मतलब कि फीड नंबर 1 एंड 5 में कोई डिफरेंस नहीं है. आप देख सकते हैं कि फीड 2 पे B है, यहाँ पे भी B है, तो फीड 2 एंड फीड 5 में कोई डिफरेंस नहीं है. मान लो कि यहाँ पे C है, यहाँ पे भी C है, तो फीड 2 और फीड 4 है, उसमें कोई डिफरेंस नहीं है, चाहे फीड 2 खिला दो या फीड 4 खिला दो. एंड ओनली द डिफरेंस हियर, एक सुपरस्क्रिप्ट यही बचा है, वो अकेला है, सो फीड 3. सो वी कैन सी यस फीड 3 इट इज सिग्निफिकेंटली डिफरेंट फ्रॉम द रेस्ट ऑफ द अदर फीड्स. ओके, so for comparison of this different treatment group we can use the CRD, but only when the experimental material it is homogeneous. Another design, that is the RBD. So hurriedly I will finish it. RBD, that is the randomized block design. So when your experimental material it is a heterogeneous, मान लो जैसे मैंने अभी एक पिक्चर बताया शीप का, अगर मान लो कि वही शीप के पिक्चर में एक छोटा होता है, एक बड़ा होता है, एक काले मुंह वाला होता है, एक ब्राउन मुंह वाले होता. ओके, किसी के सिंग होते, मतलब किसी का बॉडी वेट कम होता, कोई दुबला होता, पतला होता. सो वी कैन से एक्सपेरिमेंटल मटेरियल इट इज कंसिडर एज अ हेट्रोजीनियस. तो जब भी योर एक्सपेरिमेंटल मटेरियल इट इज अ हेट्रोजीनियस, यू हैव टू गो विद द RBD. जैसे मान लो कि मैं आई एम डूइंग द एक्सपेरिमेंट ऑन द एनिमल. ओके, तो मैंने मान लो कि एक्सपेरिमेंटल एनिमल में मैंने शीप ले लिया. ओके, शीप में भी तो कई वैरायटी है. मैंने मान लो कि पाटनवाड़ी शीप है, मारवाड़ी शीप है. अब शायद आपने एनिमल साइंस से नहीं है तो आपको मालूम नहीं होगा. सो एनिमल में भी वेराइटी होती है। आपने देखा होगा कि भाई काऊ होती है तो उसमें भी देसी काऊ, कांकरेज काऊ होती है, गीर काऊ होती है, HF क्रॉसब्रीड होती है। सो अगर आपके पास ऐसे हेट्रोजीनियस मटेरियल है, आपके पास एक्सपेरिमेंटल मटेरियल है जो आप जिस पे आप एक्सपेरिमेंट करने वाले हैं, उसमें कई एनिमल गीर के हैं, कई कांकरेज के हैं, कई वी कैन से HF के हैं। सो हियर वी कैन से एक्सपेरिमेंटल मटेरियल इट इज अ हेट्रोजीनियस। तो यहाँ पे आपको थर्ड प्रिंसिपल यूज करना पड़ेगा, और थर्ड प्रिंसिपल दैट इज द लोकल कंट्रोल, and we have to divide your experimental material into the different block, and on that basis we have to do the RPD. तो यहाँ पे आप देख सकते हैं कि CRD में मैंने कंपेयर किया था 5 डिफरेंट फील्ड्स ओनली, बट यहाँ पे आप देख सकते हैं कि 4 डिफरेंट ब्रीड है। तो यहाँ पे ब्रीड इफेक्ट भी मुझे इंक्लूड करना पड़ेगा। तो यहाँ पे वन मोर इफेक्ट आ गया, ब्लॉक इफेक्ट आ गया। तो यहाँ पे फीड, बिटवीन फीड भी आ गया, बिटवीन ब्रीड भी आ गया। ओके, सो दिस इज द कैलकुलेशन पार्ट। ओके, सो दिस इज वी कैन से बिटवीन ब्लॉक, दिस इज एनोवा। तो यहाँ पे आप देख सकते हैं उसमें CRD में 3 ही कंपोनेंट थे, बिटवीन ट्रीटमेंट, एरर एंड टोटल। तो यहाँ पे वन मोर एडिशनल सोर्स ऑफ वेरिएशन आ गया बिटवीन द ब्लॉक। ओके, क्योंकि ब्लॉक मतलब ये ब्रीड वाला ब्लॉक। So these are the degree of freedom. This is the calculation is here as I shown, and here on the basis of this calculated F value, we can say that yes, there is a significant difference between the breed or not. Is there any significant difference between the treatment or not? That we can know from this ANOVA. Then RBD that have a lot of advantage. So it is definitely it is superior than the CRD when your experimental material it is a heterogeneous, because everywhere you will not get the experimental material it is a homogeneous. आप कभी भी कोई भी स्टडी करने जाएंगे एक्सेप्ट द लैब एनिमल, लैब एनिमल में आप देखोगे तो होमोजेनस मटेरियल मिल जाएगा, लेकिन लार्ज एनिमल में जाएंगे, कोई अदर ट्रायल में जाएंगे तो डेफिनेटली आपको जो आपका एक्सपेरिमेंटल मटेरियल होगा वो हेट्रोजीनस ही होगा, वो डिफरेंट ही होगा। ओके, सो अगर आपका एक्सपेरिमेंटल मटेरियल हेट्रोजीनस है देन बेटर टू गो विथ दिस RBD इंस्टेड ऑफ दिस CRD. So these are the certain advantages are there, okay, and disadvantages are there. Here you can take the maximum number of treatment, it is a 12. Okay, उससे ज़्यादा आप treatment group compare करने जाओगे तो it will give the some we can say error, okay, because the homogeneity within the block assumption will be violated. So these are the disadvantages. This is the calculation part. Okay, try to understand it. And here you can see here between field it is also significant. So yes, definitely between field significant. So here these are the comparison of the ANOVA of the CRD and RBD. ये ऊपर वाला RBD का है between treatment, between block, error and total. Here you can see it is a between treatment, error and total. Other experimental design, it is a Latin square design and factorial CRD. So factorial CRD may be 2 factorial CRD, 3 factorial CRD, 4 factorial CRD. Then factorial RBD, उसमें भी 2, 3, 4 factorial RBD है. Then repeated measured ANOVA. So lots of design are there. Split plot design, then we can say switch over design. So all are not useful for you. Okay, so if you want to go with the design, so definitely it will be only the CRD or RBD will be applicable to you. Okay, or sometime if you have only 2 group, then it will be the T test. Okay, so this is about the basic of statistic and experimental design. So thank you very much.
Thank you very much, Doctor, for giving us an overview of different components of biostatistics and experimental design.
Thank you, sir. Thank
students, if you have any queries, you can ask Dr. Ashish. Any doubts or clarifications?
So student, if you have any, yes. कोई पूछना चाहता है?
Good morning, sir. I have a basic doubt.
Yeah.
You had mentioned a number of degrees of freedom for error. How like can you define that? I don't understand that.
Degree of freedom. So
And degree of freedom of error.
Okay, here. Here, can you able to see the PPT?
Yes, sir.
Here. So here you can see, first I will show you about CRD. तो आप CRD में देख सकते हैं कि यहाँ पे कितने फीड है, 5 different feeds है. Okay, now you see the ANOVA. So here between feed, तो यहाँ पे 5 feed थे, तो 5 minus 1, so it is a 4 degree of freedom हो गया यहाँ पे. Now total degree of freedom कितना हुआ यहाँ पे, total how many animals are there? So here it is a 5 into the 4 replication, so it is a 20 animals. So here it is a total 20 minus 1, so it is a 19 degree of freedom. And 19 minus 4 करेंगे तो error degree of freedom आ जाएगा. Or you can use this formula also, n minus f. So n that is the 20 and f that is the number of feeds. So here 20 minus 5 करेंगे तो आपको 15 मिल जाएगा. Okay. So here likewise you can find out this error degree of freedom.
Okay, sir. Yeah, now it's better clear. Thank you.
Welcome. So if you have any doubt, you can ask anytime. Okay, आपको मेरा email ID मैंने PPT में रख दिया है. You can ask anytime. आपको जब भी स्टैटिस्टिक के बारे में समझना है, कोई गाइडलाइन मतलब कोई गाइडेंस लेना है कि भाई मैं कौन सा डिजाइन यूज करूं, कहाँ से, which freely tools are available. Okay, so at that time you can ask anytime. Okay, and certain tools are also available. If time is there, I will show it. तो यहाँ पे आप देख सकते हैं कि एक WASP सिर्फ आप इतना सर्च मारिएगा. कैन यू एबल टू सी?
Yes, doctor.
So you simply search WASP ICR Goa, okay, on Google. So you will find the statistical package WASP. Okay, here WASP 1 and WASP 2 are there. This is online tool, okay, freely available. You can do the analysis at your own also. So here WASP 1 is there. So here you can see the basic statistic, as I told, descriptive statistic, T test, that is the 1 sample, 2 sample, pair T test, chi-square test, correlation, regression, experimental design, CRD, RBD, Latin square, factorial CRD, split plot, strip plot. All the basic statistic analysis can be done by simply this web agri stack pack. That is the WASP. Okay, तो आप इसका भी यूज कर सकते हैं. Okay, आपको डेटा एनालिसिस करना है. Okay. Or otherwise, if you have any doubt, you can ask anytime through either mail or by phone also. Okay. Okay, sir.
Okay, doctor. Thank you so much for taking.
Okay, welcome, sir. So I am leaving now, sir.
Yes, thank you.
Okay, thank you.
Dr. Shahina, are you with us?
Yes, sir. Good morning.
Yes, doctor. Thank you. Welcome.
Thank you.
Students, our next lecture, we will continue with our next lecture. So Dr. Shahina is with us today. She is from Department of Biostatistics, National Institute of Research in Reproductive and Child Health. She is working there as a scientist E. Dr. Shahina has her PhD from AIIMS, New Delhi in Biostatistics. She has also worked as a senior research fellow in National Institute of Medical Statistics and a statistician at the Population Council, New Delhi, and also as an assistant professor in R.D. Gardi Medical College, Ujjain, before joining the National Institute for Research in Reproductive and Child Health as scientist in 2015. Her research interests are in reproductive health and clinical trials. Dr. Shahina has published more than 30 research papers in reputed national, and international journals. So today, Dr. Shahina will be taking a next session in analysis of variant and multivariate analysis. Dr. Shahina? Yeah.
Yes, sir.
The floor is yours.
Yeah, thank you. So, can you see my PPT, sir?
No, not yet.
Just a second. I have to just click the PPT now.
Share screen, you have the share screen option?
Share screen.
Yeah.
Just a second. Achha, sorry. Now you can see that?
Yes, doctor.
Yeah, thank you.
You can go to the full screen mode.
कट कर दो या तो बोल दो कि yeah. Hello.
Yes,
Good morning,
doctor.
student. Good morning, students. So the topic was given to me is analysis of variance and multivariate analysis. I was listening to the earlier lecture and the analysis of variance topic was covered by the speaker.
He gave some introduction for you.
So, okay, fine. We'll see how to use statistical software to do the analysis of variance. Okay. So before jumping to the topic, I would like to give a brief intro about the health research, because in earlier topic, the speaker covered the animal research. Okay, broadly we are doing in health research, broadly there are three categories. One is observational research, the another one is experimental research, and the last one is translation or implementation research. These are the steps of any scientific health research. Okay, so what we cover under each research. So in observational study, we generally cover the burden of the problem. It may be disease, or we will try to find out the risk factors of that disease. Okay. And in the next step is when you know the burden and the risk factor of disease, you will try to find out some strategies, intervention, tools, device, algorithm, drug, or vaccine to reduce the burden of disease. Okay. Then when your intervention shows some significant impact, then you translate this into the policy or into the practice. So first of all, I would like to keep our lecture as interactive if it is possible. So now I like to ask the students, can they give some examples in observational study or experimental study or translation study? Anyone?
Students, you can switch on your videos and you can interact with Dr. Shahina. Make it this an interactive session. Otherwise, statistics is very boring.
Yes.
Come on, students. Yeah.
Yes, Arushi, please.
Ma'am, actually, since the topic is new, I'm not exactly sure, but observational study may include talking about like observing different results, like different tests, which we do on a problem like maybe Alzheimer's or Parkinson's, and then we can get some sort of data from it and weigh the issue.
Mm-hmm. Okay, for example, nowadays, COVID is very much prevalent. Okay. try to put COVID example in this scenario. First of all, what is burden? Burden means prevalence or incidence, or the number of people affected with COVID cases, number of deaths due to COVID. These are all kind of observational study. What are the factors? What are the risk factors associated with COVID? Means how people are contacting this disease. Okay. That is virus, touching. If we take these two examples. Now, if you come to the experimental study, they have taken some preventive measures. What are the preventive measures? To reduce the burden. Wear a mask.
Use of sanitizers.
Yes. Hand washing.
Social distancing.
Social distancing. These are the three methods. And behavior change. These are the preventive measures. What are the behavior change? These are all behavior change, no? How they have created awareness about this preventive measures? They have spread this preventive measures through when you call, use your mobile. You will get, earlier you used to get a message. You remember? So mass level pe they have taken, they have used mobile app to spread this preventive measures to reduce this burden. Clear? Now come to the vaccine. Again, they have developed, they did some clinical trial to show that Covaxin, Covishield, or other vaccine are effective in reducing the death due to COVID. Okay, if we are doing any kind of intervention, this will come under experimental study to show the efficacy or effectiveness of your innovative idea. Okay, and how translation and implementation, then they make the policy. You have to take the vaccine to prevent further. Please, you can prevent. It is not 100% preventive, but it is effective. Clear? So this is how the health research and the study design is related to each other. Okay?
Doctor,
Then,
your slides are not moving.
huh?
Your slides are not moving. Still in the first slide.
This is no.
No. Still in the title slide. It is not moving. Change.
But it is showing you are sharing a screen. Take a second. I will exit and again I will.
Just close this and you can again share.
Okay, okay.
Yes, doctor. Now it is okay.
Ma'am,
now it is clear.
Yeah.
Ma'am, sorry to interrupt, ma'am. I have a small doubt. Actually, the dosage of vaccine, it comes under which study, ma'am?
Experimental study.
Okay, ma'am. Thank you.
You are doing the experiment, na? And you are deciding how much dose is effective, safe.
Yeah.
There are clinical trials. There are different phases of clinical trial. Okay, there are first phase, second phase, third phase, and fourth phase. The first and second phase are for toxicity, defining dose. And in phase 3, when you are testing it on human, in a large scale to see the effectiveness. And phase 4 is for after when it comes to the market and you wanted to see the effect of this, that is post-trial effect, when it comes to the market and how it is affecting and how it is side effects, all these things, that is in the phase 4.
Okay, ma'am. Thank you, ma'am.
Yes. Thank you. Now the next, okay. Now, how to select your topic to do any kind of research. Okay. So being what we are doing, we are working with the government. Okay. So whatever national policy is there, we have to work accordingly. Whatever goals government set to improve the quality of life, we have to work accordingly. So if you came across the sustainable development goals, here you can see there are 17 sustainable development goals. And if you see the area, they have included all, including poverty, hunger, health, education, gender equity, water sanitation, energy, economic, industry, inequality, then cities, urbanization, then you can say consumption and production, climate, below water, land, everything. And everything is affecting human beings. Okay. And in under each SDG, they have set some target, measurable target to achieve in 2030. Okay. Likewise, if I will say in regarding maternal mortality, they have said that they have reduced the maternal mortality up to 100 by 2030. Now, what we have to do, we have to find out some strategies to achieve this goal at 2030. Okay. So now if you want to select your area of research, then you can read this sustainable development goals and try to find out the area of research. Okay. Now, if we go next, what is the next step? If I'm interested in health, then I will go to this, then I will find out my area of research. Since we are working in the reproductive and child health, so we will select area related to reproductive and child health. Okay. So if you have developed your research question, so there is a this, you can say this is the finer, this is short form of feasible, interesting, novel, ethical, and relevant. Your study should, this finer will guide you to conduct a research. For example, F stands for feasible. Whether you have enough fund to do this research within a stipulated time period, means how much time it will take to show your result, 1 year, 2 year, 3 year, 5 years. Whether you have technical experts, means research is not a single man show. Okay, you need epidemiologists, you need a statistician, you need clinician, you need social scientist inputs to do the research. Okay. Now subjects, who are the participants and whether you can recruit them easily. Okay. Now, whether it's interesting, the research should be interesting to the scientific community and also to the subject so that they can participate in the study. Now, novel. Novel means what is new in your research, because when you do the research, whenever you select a topic, you have to do lots of research review, whether what are the research has been conducted, and try to find out the gaps existing and try to build a good rationally why you want to do this research, strong rationally to convince your scientific community, scientific expert or peer to do this research. Okay. So the next is ethical. When you are recruiting any human subjects, अगर आप किसी भी woman, men, person किसी को भी ले रहे हैं, तो you have to ensure the safety. There should not be any harm or risk, not only physical but mental also. Then safety, privacy, and confidentiality of the data. Whatever information they are providing, that should be confidential. You should not share with outside the research committee. And relevant. Relevant means what? Your research should be reproducible. It's not that if someone want to replicate it, it should be reproducible, applicable. That means if it is effective, how you are going to implement at a large scale. Statistically significant, matlab, this should be, your research should be.
Excuse me, ma'am.
Yes, bolo.
Ma'am, your slide is not moving actually.
1 second. Is it visible now?
Yes, ma'am.
I will not go into the this mode, slideshow then. Okay? It is visible now?
Yes, ma'am. Now it's moving.
Now it's moving now. Now we were here.
Yes, ma'am.
Okay? Final example. So this is clear now, na? Anyone has any question? Yeah?
Yes, doctor, it is clear.
Yes. Now the next step. What is the role of a statistician in any scientific research? Okay. So when you have developed a research question, now you have to formulate your research question into a objective. Objective should be measurable. Means ultimately at the end, आपको दिखाना है कि this many percentage of people are affected with COVID, or this much is effectiveness of this much death can be reduced by using covaxin, kind of thing. That should be measurable. Okay? And you can test hypothesis you have learned in the previous lecture. So define your research question or formulate your research question in terms of objective or in terms of hypothesis you are going to test. Based on your objective and hypothesis, study design should be selected. Either it will be cohort, cross-sectional, case control, RCT, community trial, behavioral trial, whatever it may be. So based on the objective and hypothesis, study design has been selected. Based on the study design, the sample size will be selected. Okay. Then sampling, you have heard ki you have to use, there are different kind of random sampling, simple random sampling, systematic random sampling, stratified random sampling, probability proportional to sampling. There are different methods based on the cost, sample, and your objective. Sampling is adopted. Now, after that, you define what all information you are going to collect. That we call the variables. Okay? Whatever parameters you are going to select, whether age, sex, education, history of any morbidity, so many things, our blood parameters report, whatever may be, they are called the variables. And variables should not be from your own created. It should be well validated. Okay, whatever question you are going to ask, it should be validated. So better you take this from the literature. Otherwise, you have to validate and then you use it into the into your research. Then you collect data. Data collection may be either face-to-face interview or through self-administered question. You can, in COVID, during COVID time, they used online and mobile phone to collect information. Then data analysis, and you apply some statistical technique to show that your findings are significant or not, interpret it accordingly, and conclude. That will ultimately answer your question. Okay, clear? Now we will go to the next is, I'm directly jumping to data analysis. Now there are two types of variables. One is quantitative and another is qualitative. Quantitative means you can measure it like height, weight, BMI, whatever unit is there, that is quantitative variable. Qualitative means it's, you can't measure, like gender, then good example is gender. And you can convert quantitative variable into qualitative variable, like if HB is quantitative variable and you have categorized it into anemic, no anemic, then it become a qualitative variable. And if you have categorized BMI into normal, overweight, underweight, then it's become qualitative variable. Clear? So before any analysis, you have to be, you should know type of variable, because all the hypothesis, the test of hypothesis, whatever it is depend upon the type of variable is there in your data set. Okay. There are two types of distribution in the while you are testing a hypothesis, and if you know that there are parametric and non-parametric tests are there. So we are focusing on parametric since they have given me ANOVA. So I will be focusing on parametric. So it is already covered. It will follow some distribution. Okay, that is why means your outcome variables. Outcome variables means you are interested in to show that this is going to decrease or increase after the completion of a study. You are interested to show the impact of the results. Okay, so it should follow the normal distribution. It should be independent and drawn from the same population. So for example, if we see it is a experimental study. So if you want to see which intervention is more effective in lowering the cholesterol level in overweight males, exercise or diet. Okay? So what do you understand by that? ये एक एक्सपेरिमेंटल डिजाइन है जिसमें हमने 100 सब्जेक्ट लिए हैं, 50 randomly allocated to diet program and 50 randomly allocated to exercise program. At the end, and who are the participants here? Here the participants are overweight males. Okay? And at the end, you want to see which one is more effective. What is the hypothesis here? First, we assume that intervention has no effect. Means at the end, we will get the equal means. But what we are trying to see, that is alternative hypothesis, no, at the end we will get different mean. And this is what we want to prove. Okay. Now, this is just a theory. When we do, when we test some hypothesis, we are committing two types of error because we do not know the true situation. Fine. It has been covered or not covered in earlier I mean in previous day or any lecture. Hello. Hello.
Hello. It's
Yes.
not covered, I think.
It's not covered. Okay.
Yeah.
So I will tell you one example. For example, if you imagine a court scene, okay, there is one judge and there are two lawyers, and there is one guilty person, and one is producing evidence against, and one is producing evidence in support of this. Based on their evidence, the judge will decide will make the decisions. Okay, but you don't know whether the person is guilty or not guilty. Okay, the decision may be correct, the decision may be wrong. So there are two types of errors involved. Okay, according to you, which one is more serious? अपराधी को छोड़ देना या जो अपराधी नहीं है उसको सजा देना? Anyone?
जो अपराधी नहीं है उसे सजा देना।
अच्छा, अपराधी को छोड़ देना?
अगर उन दोनों में हम कंपेयर करेंगे तो जो निर्दोष है उसे सजा देना ज्यादा अनजस्ट होगा ना।
ठीक है, हाँ, वो है कि जब तक प्रूफ नहीं कर पा रहे हैं तब तक आप कुछ नहीं कर सकते। ठीक है, तो वो मान के चल रहे हैं कि जो आपके पास जो कटघरे में खड़ा है वो अपराधी नहीं है, तो इसीलिए हम भी यहाँ पे रिसर्च मान के चल रहे हैं कि जो नहीं है, कोई डिफरेंस नहीं है। जो पहले स्लाइड में मैंने दिखाया कि दोनों में कोई डिफरेंस नहीं है। ठीक है, तो ये जज मान के चलता है, बेस्ड ऑन एविडेंस ही विल प्रूव वेदर देयर इज अ डिफरेंस और नॉट। ठीक है, तो देयर आर टू टाइप्स ऑफ, आप इसको समझ लीजिए कि जब आप डिसीजन ले रहे हैं, ये कॉलम में जब आप डिसीजन ले रहे हैं, यू आर रिजेक्टिंग योर हाइपोथेसिस, बट इन ट्रू सिचुएशन हो सकता है कि कोई डिफरेंस ना हो। ठीक है, तो आप एक डिसीजन गलत ले रहे हैं, बट अगर आपने डिसाइड किया कि यस देयर इज नो सिग्निफिकेंट डिफरेंस एंड यू आर नॉट रिजेक्टिंग योर नल हाइपोथेसिस, बट एक्चुअल में वहां पे डिफरेंस हो सकता है जो आपने फाइंड आउट नहीं किया, फिर भी आप रॉन्ग डिसीजन ले रहे हैं। ठीक है, दीज आर द टू रॉन्ग डिसीजन एंड दीज आर टू करेक्ट डिसीजन। मतलब आप नल हाइपोथेसिस रिजेक्ट कर रहे हैं, एंड में बता रहे हैं यस देयर इज अ सिग्निफिकेंट डिफरेंस इन द कोलेस्ट्रॉल लेवल and in reality also this exists, that means your correct decision. ठीक है, when you calculate the, ये देखो type 1 error is rejecting H0 which H0 is true, and type 2 error is accepting H0 which H0 is false. So when you calculate the probability of type 1 error and type 2 error, so in statistics we denote it by alpha and we say it is the level of significance. Type 2 error denoted by beta, and if you take 1 minus beta, that means rejecting H0 when H0 is false. ठीक है, so यहाँ पे अल्फा आ गया, बीटा आ गया। और एक चीज बताना चाहते हैं, these two are inversely related। ठीक है, अगर आप एक को कम करोगे तो दूसरा बढ़ेगा, ठीक है, दूसरे को कम करोगे तो पहला बढ़ेगा। तो आपको ऐसे प्लान करना है कि दोनों ही मिनिमम लेवल पे रहे। ठीक है, तो अभी आपको क्या करना है, अगर मैं ये स्लाइड में जाऊं, ठीक है, यहाँ पे देखिए, when we do research, so we are concentrating on this part, ठीक है, we will try to reject H naught and we try to prove our hypothesis कि yes there is a difference between the two groups, ठीक है। तो हमारे हाथ में क्या है, अल्फा है एंड 1 माइनस बीटा है, ठीक है। 1 माइनस बीटा इज व्हाट, पावर मतलब denoted as power and alpha. So what we do in research, we fix this alpha. Before conducting any study, we fix these two. Alpha को 5% पे कि हमारी type 1 error should not be more than 5%. ठीक है, by default this is 5%. And the power of any study, we will try to fix it at 80%. अब power समझ में आया, what is power in layman language? layman language में अगर मैं बोलूं तो आपको एक कमरे में एक सुई ढूंढनी है, ठीक है, तो आप कैसे ढूंढोगे? टॉर्च लेके ढूंढोगे, लाइट जला के ढूंढोगे, मैग्नेट लेके ढूंढोगे, कैसे ढूंढोगे? हेलो, आप बताओ तब मैं आगे बढ़ती हूँ ना। हेलो, टॉर्च लेके ढूंढोगे, मोमबत्ती लेके ढूंढोगे, मैग्नेट लेके ढूंढोगे, क्या लेके ढूंढोगे अगर आपको एक निडल ढूंढनी है कमरे से?
Magnet.
Why? Because it is more powerful, ठीक है, to find out the small difference. एक छोटे से ऑब्जेक्ट के लिए आप इतना मैग्नेट लेके जा रहे हैं, ठीक है। तो यहाँ पे when I am saying this m1 is not equal to m2, ठीक है, I am not specifying how much difference is there, ठीक है, दोनों में कितना डिफरेंस है, 2 है, 5 है, 10 है, 20 है, ठीक है, कितना है, हाउ मच डिफरेंस यू आर गोइंग टू फाइंड आउट और हाउ मच डिफरेंस यू आर एक्सपेक्टिंग टू फाइंड आउट. So that is the difference you are going to detect through your experiment with enough power, कि मेरे पास इतना पावर होना चाहिए to detect this difference, ठीक है। मैंने बोला डाइट से कोलेस्ट्रॉल लेवल कम होगा, एक्सरसाइज से भी कोलेस्ट्रॉल लेवल कम होगा, बट कितना कम आप एक्सपेक्ट कर रहे हो? 5%, 10%, 20%। जितना बड़ा आप डिफरेंस एक्सपेक्ट करोगे उतना पावर आपको कम लगेगा। जितना आप छोटा डिफरेंस डिटेक्ट करना चाहोगे तो आपका पावर मोस्ट पावरफुल होनी चाहिए आपकी स्टडी, और ये आपका डिपेंड करता है सैंपल साइज पे, ठीक है। जितना स्मॉल डिफरेंस आप डिटेक्ट करोगे आपका सैंपल साइज उतना ज्यादा होगा, और जितना वाइडर डिफरेंस आपका डिटेक्ट होगा उतना सैंपल साइज आपका कम आएगा। आपके सैंपल साइज लेक्चर में दे आर गोइंग टू डिटेक्ट इट, इसलिए आपकी स्टडी में स्टडी शुड बी एटलीस्ट 80% पावर होना चाहिए, ठीक है। एंड द कॉन्फिडेंस इंटरवल इट इज बाय डिफॉल्ट इट इज 5%, ठीक है। देन ओनली and do the sample size calculation. Otherwise हो सकता है at the end में you see the non significant, आपको हो सकता है finding ना मिले अगर आपने sample size नहीं calculate करी at the end में, अगर आपको you have found out कि there is no significant difference, then calculate the power. If it is less than 80%, that means your study was not power enough to find out the significant difference. You may recommend that कि you can reproduce this study by increasing the sample size, ठीक है। So here there are only 2 groups, so we are using, and they are independent sample, so we are using T test, independent T test, to see the whether there is a significant difference in the mean level of cholesterol or not. So we have applied using our, if you apply it, you will get a t-value. P-value by software, you will get p-value, but in, and you can conclude that yes, there is a significant, statistically significantly lower cholesterol concentration at the end of exercise training program compared to diet control. See, there is a around 2-point difference, and this is the p-value. This is how you, but this is from the software output. Okay, but if you want to use manually, then you have to calculate p-value using this formula. Then degree of freedom, you know that n1 plus n2 minus 2, in this case 100 subjects, minus 2 is 98, and t tabulated means at 98 degree of freedom, what is the values? This is degree of freedom, and at 5%, this is 5%, you will see after 60 it is around 1 point something. So I have written approximately. If t calculated is greater than t tabulated, then we will reject the null hypothesis. This is the, by earlier when software was not there, then we used to do like this. So now the software are there, we get exact p-value, and based on that we decide whether our null hypothesis is rejected or accepted. Clear? So these, if there are two groups. If there are one more intervention, means if there are 3 categories, for example, this exercise, diet, or both. Means some people are doing exercise and diet both. This is your null hypothesis. This is your alternative hypothesis, assuming that at least one, any one of is different from other. Okay. If more than 2 groups, then you use ANOVA. You cannot use T test कि M1 M2 देख ले, M2 M3 देख ले, and M1 M3 देख ले, because the error you have, type 1 error जो आपने 5% fix की है, that will increase to 15%. तो आपके जो नॉन सिग्निफिकेंट फाइंडिंग होगी ना, वो यहाँ पे सिग्निफिकेंट आएगी. ठीक है, तो don't use this. So this is the extension of independent T test. You first use ANOVA. ठीक है, ANOVA करने के बाद you will come to know post hoc test में कि which 2 groups are significant. ठीक है, क्लियर हो गया? ये ANOVA का फॉर्मूला है जो सर ने पहले ही कर दिया, बता दिया. This is what we get. So ये है diet, exercise or both, mean SD, this, and this is the p-value. That means there are significant difference in mean levels of cholesterol concentration among the groups. Which group, उन्होंने postdoc test हम देखेंगे कैसे लगाना है और कैसे करना है. ठीक है, this is ANOVA. So if you keep on adding number of factors, मान लीजिए अभी आपका ये सिर्फ मेल है, अगर आप फीमेल में भी देखना चाहते हैं, ठीक है, आपने डेटा कलेक्ट किया मेल फीमेल, देन तीनों को इंटरवेंशन दिया, नाउ यू वांट टू सी, एंड एजुकेशन इज वन ऑफ द फैक्टर, क्योंकि दो, और एडहेरेंस टू द प्रोग्राम, दैट इज वन ऑफ द फैक्टर. तो आपका इतने सारे फैक्टर इज गोइंग टू अफेक्ट योर आउटकम. सो in that case, when you are dealing with multiple factors simultaneously, then we use the regression analysis. Okay, that is what we call multivariate analysis. There are different types of regression analysis based on your outcome variables. We have to select the regression. Okay, linear regression is there, logistic regression is there, multinomial logistic is there, and so many more are there. Okay, I don't know how much time I have, but I will show you the अभी तक किसी को कुछ पूछना है तो पूछ सकता है. ठीक है,
Students, if you have any clarifications, you can ask Dr. Shaheen. You can also use the chat box to ask questions.
Is this screen is visible, sir?
Yes,
Data?
doctor. Yes, doctor.
Yes, okay. Thank you. कितना टाइम है मेरे पास सर अभी?
Can go for 7 minutes, 12:30.
Okay, okay, okay. Thank you. ठीक है, no question. ठीक है, we are using SPSS. ठीक है, this is the statistical package for social science. Since we have a licensed version, so I will show how we are doing analysis using this. So this is same as you can see is look like Excel sheet. Excel sheet की तरह दिख रहा है. The columns are the number of variables and the rows are the number of participants in this study. So here there are, if you see, there are 102 participants. This is just hypothetical data, okay? And these are the variables. And if you see the variables, disease, I have coded it as a 0 and 1. Means 0 means no disease, 1 is disease. Smoking at status, 0 means no smoking, 1 is smoking. Then intervention, I have categorized it into 1, 2, 3. Gender as 1, 2, 1 is male, 2 is female. Group, there are 3 groups, 1, 2, 3. Okay? And these are all, you can see, continuous variable. Okay? Measures, and these are all, if you see, these are जो 3 balloon की तरह बने हुए हैं. These are all categorical, qualitative variables. Now, here there is a command, analysis. The first is, if you want to see the frequency of any, okay, if you click it, for example, disease and smoking, the number of variables, whatever you want to do, intervention, and press OK. This is your output. Okay. Here you can see smoking, there are 57%, 42% were smokers. Then gender, 51% are male, female and female. Intervention in diet chart. In each group, there are 36, 31, 35 cases. Out of that, this is the percentage. Okay. So if you want to do the T test, so we are comparing means. Here there are different, we have to select the independent sample T test. Okay. For example, if there are 2 groups, for example, I want to see the blood parameter or hormonal level. I have to define 1 and 2, means I have coded gender as 1 and 2. That is why it is asking. I will click this. Okay. If you see this T test, these are the mean and standard deviation. And here you can see F test, significant, T
The
test.
results are not showing.
रंजन रिजल्ट नहीं दिखेगा, कैसे होगा फिर? कैसे पूरे स्क्रीन शेयर करेंगे? ये दिख रहा है.
Yes.
ये एनालिसिस में
analysis part is not showing. Final output is not showing.
नहीं, अगर मैं इसको कर रही हूँ ना, ये आ रहा है तो ये कैसे जाएगा उधर? नहीं दिख रहा है, आउटपुट नहीं दिख रहा है. Now you can see that.
Yes, doctor, we can see that.
Okay. अभी मुझे कैसे करना पड़ेगा? ये भी दिख रहा है सर?
Yes.
ओके, ठीक है, थैंक यू. ओके, ठीक है. तो what I was telling, if we do the descriptive statistics, if you want to see the frequency, I will say it. ठीक है. So I want to see the frequency of my data. I will press OK. Here you can see. This is the frequency distribution, number of cases in each category and the percentage. ठीक है. For example, in intervention, you can see 36, 31, 35 number of cases in each category, and this is the percentage. Fine. Now, if I want to, first I will use, if you want to compare the means between the groups. So if you want to see how the T test is being used, I will reset it. These are the hormonal parameters, and I want to use it by, I want to test it between male and female. So I will code it as a 1, 2. Because I have coded gender as 1, 2, that is why it is asking. I will press OK, then it is giving you the results. This is hormone 1 between male and female. What is the mean standard deviation and standard mean error? Okay. So this is what the output of independent sample T test. If you see for hormone 1, F test significance, not significant. This is T value, this is degree of freedom, and this is showing significant result. Okay. So this is what is two-sided. We'll say this is the significant findings. Others are not significant, and the hormone 4 is significant. Only 2 hormones, these are coming significant. Difference in male and mean level of hormonal levels are significant between male and female. Clear? Now, if you go to the how to do the ANOVA, here it is one-way ANOVA. So ANOVA, maybe I will take all the hormone and I will go for intervention. There are 3 intervention. I will place click. If you see, only the hormone 2 is coming significant, right? All the hormone 1, hormone 3, hormone 4 is not coming significant. So if you want to know which pair of your group is coming significant, we will do again, we'll go to one postdoctors. I will select bone Farani, continue, okay. Only I will select the only hormone 2 is coming significant, so I will select only 2. ठीक है. अभी आप देखो, diet is significant with exercise and diet is significant with सारे ही significant हैं. ठीक है ना. Diet with exercise, there is a significant difference. Diet with both, there is a significant difference. Exercise and diet, they all are significant. This is hypothetical data and you are getting the all are diet or exercise significant. Diet with both is also significant. Clear हो रहा है? Exercise and this both is also significant. ठीक है? But based on the mean and but based on this mean level of cholesterol level or hormonal level, you can say that whether there is a significant decrease or increase. Based on this p-value, you can conclude. ठीक है, क्लियर हुआ कि नहीं हुआ? हेलो,
Yes, ma'am. Clear.
क्लियर है ना? नाउ दिस इज एनोवा. अगर आपको बहुत सारे टेस्ट हैं, दीज आर एनोवा. फॉर एग्जाम्पल दिस इज आपका two-way ANOVA. If you want to use, you can use it from here. I will take hormonal as a dependent variable. Intervention is one factor and gender is one factor. If you press OK, then you see that there is no interaction between gender and intervention. मतलब in case में कोई impact नहीं है, direct impact आपका intervention का है. Main impact is because of intervention. जेंडर के साथ इनका इंटरेक्शन जो है दैट इज नॉट सिग्निफिकेंट. ठीक है, दिस इज योर two-way ANOVA. When you are using the factorial design, so you will use the two-way ANOVA. Now what are the other analysis? Here you can see independent t-test, pair t-test. You know pair t-test. What is pair t-test? Before and after observation. Before doing intervention, if you have taken the cholesterol level, and after completion of intervention you have taken the cholesterol level and you try to show that yes, there is the impact of intervention. ठीक है, तो these two observation are correlated before and after. ठीक है, तो ये आता है आपका पेयर टी टेस्ट में. So this is all about mean correlation. If you want to see the linear relationship between the quantitative variables, so this is your correlation. Hormone 1 is negatively correlated with hormone 2, positively correlated with hormone 3, and positively correlated with hormone 4. And the second one is the p-value. If you see, only the hormone 4 is significantly positively correlated with hormone 1. Okay, so this is how we interpreted the correlation. Now coming to the regression. So regression analysis, linear regression, and there is binary logistic regression. So if you select the binary logistic regression, means your outcome variable is categorized it into the two categories, either disease or no disease. So if I will select, this is your outcome variables, and what are the factors responsible for this disease? It may be hormonal, gender, or what is the, if they are doing some physical. Okay, so all the variables are taken into account, and I don't know whether disease is coded as 1 or 0 or. Okay, so this is the output of your logistic regressions. So these are all how the model is behaving, model summary is good or bad. So this is the output. Okay, this is the output where you can see which are the significant variables are significant. Only one variable, that is the hormone 4, is coming significant. Rest are not significantly contributing to your outcome variable. Okay, and how much they are contributing means 1.81 times. If you increase the mean, this is what continuous variable. Okay, so if you summarize the continuous data, it will be mean level. So interpretation is, if the unit of this hormone will increase by 1 unit, the outcome will be increased by 1.81 times, or the chances of disease will increase by 1.81 times. Okay, this is how we interpret the findings. Anything else? There are non-parametric tests. If you don't know, if your data if the sample size is less than 30, then we generally use the non-parametric test because we don't know the distribution of your outcome parameters. So generally, otherwise you test, there are different ways to test the assumptions of any test. So how to apply in case of this, for example, I will show you how to run ANOVA in this. So hormone 2 was significant and hormone 4, I will select 2. I will take intervention and run. So ये देखिए आया है. So this non-parametric test, generally this is Kruskal-Wallis test we use, and it is showing the significant results. Okay, so you can reject your null hypothesis and accept. This is the Boss plot of these three. These are the outliers. Before analysis, you have to check this outlier. You have to transfer the data. Then pairwise combination is also give. They are all significant, which pair. So in parametric also, we have seen that which pair is significant. Likewise, this is how we do the non-parametric test. These are all the graphical presentation of the hormones. Anything else? Baki or kya kya isme, so many features are there. Diagnostic tools are there. If you want to calculate the sensitivity, specificity, if you want to check the predictive of your model, how good your model is, they are all advanced statistics. While developing a regression model, the next phase is to test your model, how good it is to predict whether the in a reality, how to develop an algorithm based on your selected variables. These are all advanced stage of analysis. So any question, I will stop here. If someone has some queries, please ask. Thank you.
If you have any queries, you can ask students. Any questions? Okay. I think no questions, Doctor.
Okay, sir.
Yeah.
Thank you.
Thank you for your wonderful time.
Yeah. Okay, bye. Have a nice day.
Thank you. Professor, you are with us? Professor Mukesh? Good morning, Professor. Can you hear me? Professor Mukesh, can you hear me?
Yeah, I can hear you.
Yes, sir. Welcome. Good morning.
Good morning.
Students, we are going to the next session. We have with us Professor Mukesh from Iit Madras, Department of Biotechnology. He has a work experience of 20 years from Imperial Chemical Industries and General Electric Technology Centers. His area of interest are drug design, biomaterials, bioreactors, and bioremediation. He holds a BTech and MTech degree from Chemical Engineering from Iit Madras and a PhD from University of Aston Birmingham, UK, and a postdoctoral from University of Cambridge, UK, and Texas A&M, USA. Professor has authored and co-authored more than 250 technical research papers and 8 books. He is a fellow of Royal Society of Chemistry, London, and a recipient of Herdilla Award for Excellence in Basic Research from Indian Institute of Chemical Engineers and the Dow Professor M.M. Sharma Distinguished Visiting Professorship in Chemical Engineering at Indian Institute of Chemical Technology, Mumbai. He is also a editorial board member of the Journal of Chemical Engineering and Phytomedicine and a member of American and Indian Institute of Chemical Engineers. With this introduction, I welcome Professor Mukesh. Professor, the floor is yours. You can start.
Hello, everyone. We are delayed by half an hour, so it's okay. I will.
It's okay, Professor. But because of the first session, little bit the lecture is elongating. Couldn't finish it within the time frame.
Okay. Because it's lunchtime for everybody, so no problem. I will. Hello, everyone. Good afternoon. I will share my screen first. Can you see my screen?
Yes, Professor.
Okay. Good afternoon, everyone. I am going to talk about design of experiments. In fact, this is a long subject, which may take several hours, but I will try to condense it in about 40 minutes. So design of experiments are very important because before we start doing experiments in our lab or in the manufacturing industry, where we try to modify certain parameters, they are called independent variables or X's, and we try to look at a certain dependent variable, which are called Y's. So before we start those experiments, we are looking at planning of this design of experiments. These are some references which you can take a screenshot if you want to go much detail into this area of design of experiments. Okay, so why do we need to design experiments? We do design of experiments to identify important variables. Suppose I am a chemical engineer, I am modifying flow rates, temperature, pressure. So which are the important variables that's going to affect? So I need to identify. Optimize the product or process design. So I am doing a fermentation. I want to increase the yield of a product. For example, I am fermenting for preparation of ethanol, bioethanol, for example. So what are the parameters I need to optimize so that I get maximum bioethanol? Achieve robust performance so that the design is very, very stable. If I change some parameter, it's not going to get oscillated into actually. So that's why we do design of experiments. So we do in the lab, we do in a process, industry, factory, it could be an engineering process, it could be a biochemical process, it could be a chemical process. Everywhere we need to do experiments, and that is where we plan the experiments. That's called design of experiments. So basically the X's are your independent variable, okay, temperature or pressure or pH or catalyst amount, and Y is my dependent variable, which gives you like a yield, purity. Okay, so that's the Y actually. So we need to ultimately try to get some relationship between various X's with the Y. That's why we do design of experiments actually. There are many softwares also are there which can do that. But I will show you from the fundamental point of view actually. So in design of experiments, what do? We prepare the design, we collect the data that is actually in the lab. Then we do some statistical analysis. You heard about ANOVA. It could be ANOVA, it could be a T test, it could be a chi-square test, it could be a non-parametric test. And then finally we derive conclusion. Okay. and finally make a recommendation. This is the best condition. So my focus is on the first, preparing the design of experiments. I'm not going to talk about the rest actually. So the very first step is the design of experiments. So design of experiments has been used in agricultural industries, defense industry, chemical process, biochemical, manufacturing, quality control, automobile, semiconductors, and so on. You must have heard about a concept called Six Sigma. So many industries make use of this Six Sigma, including IT industries. So design of experiments is part of the Six Sigma actually. So in a design, there is always something called control, that is comparing with respect to some data, existing data. Okay, so that is called a comparison. That's very, very important actually. Good experiments are always comparative. So when I am comparing, I am introducing a new drug in the market, you compare it with some existing drug, or we compare it with a placebo. Placebo means it's not a real drug, but it is meant to overcome all the psychological effects. So placebo. Sometimes we compare it with the male and female volunteers. So any experimental design will always have a control, which could be the comparison with respect to existing drug, or somebody is not given a drug for BP, somebody is given a drug for BP, and you compare with those who are not given the drug. You compare it with the existing drug. Suppose I'm introducing a new drug, I am comparing with the existing drug. So always you should have something called comparison or the control. Next step is replication. That means we do have to do it many times. So not just doing it only once, which is totally wrong. There could be errors, experimental errors, instrument errors, operator errors, the environmental errors, and so on. So we need to have replicates. That means we need to do it many times to know what is the average. We need to know how much is the standard deviation. That is how much is the variation. Even if you do 2 times the same experiment, you are going to get different answers, because that's called a statistical variation. So replication is very, very important. You cannot just do one experiment alone with control, one experiment treated and come to a conclusion. We may have to do more. More the better, because the errors get reduced. If you look at the error was in a T table also, more number of experiments, that means more number of degrees of freedom, the error keeps coming down and down. So we need to do that. Replication is very, very important. Why replicate? Reduce the effect of uncontrolled variation, reduce quantitative uncertainty. Also, we can do reproducing and repeating, and so on actually. So replication is very, very important. Randomization. This is very, very important. I can't have a priori knowledge or a priori plan, but when I am doing an experiment, I need to do it in a very random fashion so that there is no bias coming into the picture. For example, if a doctor is asked to give test a drug for say diabetes, and he's asked to give it in a random way, he should give it randomly to the patients or whoever is coming into the hospital, not a priori knowledge of these people are having diabetes and these are not having diabetes. So you should not be giving it to only those who are having diabetes. That's called a randomization. Okay, so randomization gets rid of bias. So randomization, how does it done? For example, if you toss a coin, you get heads or tails. That's a random. If you play a dice, it may vary between 1 to 6. That's called randomization actually. So any experiment has to be done in a random way. That means I should not be doing the effect of temperature by changing it from 20 degrees, 30 degrees, 40 degrees, 50 degrees, because that gives you a uniformity, which will not be random, but it is a very planned type of experiments actually. Randomize is very important so that when you select volunteers, there is no bias coming into the picture. And randomization is very important because the probability theory on which statistics is based on randomization. Okay, so any statistical analysis is based on randomization. That's why we also have to use random approach when we do experiment actually. stratification and blocking. For example, I am looking at testing a drug, and I want to test in throughout the world. So I may take volunteers, say from Europe. I may take volunteers from Asia. I may take volunteers from America. You may get the different answers because of the genetic makeup of the volunteers. So I may do a blocking. So patients or volunteers from Asia as a block, and I can analyze the data. Volunteers from Europe as a block, I can analyze the data. Volunteers from America as a block and analyze the data, so that the variation between various continents will not come into picture. And that's called blocking. For example, I'm testing a fertilizer in some lands. So I may test it, say, for example, in Tanjavur district, or I may test it out in Coimbatore district. I may consider each region as a block and try to study the fertilizer in those farms in those blocks, actually. That's what called stratification and blocking, actually. And also, if you are using different bags of raw materials, there could be bag-to-bag variation, which may affect your overall result. So I may block a set of bags into one block, set of another bags into block 2, and so on, actually. That is called blocking or stratification. Okay. These factors are very, very important, actually. When I have to consider stratification, I may have to consider blocking, I may have to consider replication, I may have to have control, which is comparison. So I could have here, if I am testing a drug, I could have a positive control. That means I may compare it with another drug. I may have a negative control where I don't give drug to the patient, but I am studying the effect. So that's called a negative control. So I can have all these controls also. So these are very, very important when we consider, when we plan the designs, actually. Okay, for example, I am having, say, 20 males and 20 females. Half of them we want to compare it with a drug, and then other half we want to either have untreated or placebo or hold a drug. But only 4 volunteers per day, because when we are checking the properties, we can test only 4 persons per day, actually. So look at this approach. So Monday, Tuesday, Wednesday, Thursday, Friday, I am testing all the control people. That means those who are not given the drug. And then next week, I compare only the treated people. This is a very bad design. There is no randomization. Okay, so first whole week, I'm comparing all the control people, and the next week I'm comparing all the treated people, which is a wrong design. So the randomization is missing, actually. So we can do a randomized design. So Monday, first patient could be treated, that means with the drug. Second patient could be untreated, or then third patient on Monday could be again control, then treated. So we can have this type of randomization. You can see a complete randomization happening here when compared to this type of design. Okay, a block design, again, there could be a complete randomization within each block. That means within each week. Okay, if you to overcome the week by week effect. Okay, so you can see how the design planning happens when compared to this, which is more randomized, whereas this is more of a block as well. So that weak effect is to completely overcome, actually. We can even consider only adult male and do the study. That means adult male alone as a volunteer. Okay, then we can have effect of adult male, then effect of adult female also coming into the picture. Okay, we can even think about with respect to age also. Sometimes, for example, your vaccination, you have seen, no? Older people, then 45 upwards. Then we are now looking at 20 to 45, and then less than 20. That means 7 to 20. So that sort of block study can also be done. Okay, and so on, actually. So the blocking can be of various types, actually. Okay, either based on age, based on gender, male or female, based on region, North India, South India, West India, East India, or Asia, Europe. All these could be done, actually. What is a factorial design? Suppose I have 2 effects, for example, drug, I want to test with some patients with drug. I want to test some patients without drug. I give them normal diet or high fat diet. Okay, so suppose I am testing the drug for reducing cholesterol with normal diet and high fat diet. So we can have 4 different combinations, right? So I can have no drug, normal diet. That means I don't give the diet and check patients who have taken only normal diet. I can have no drug, but give them high fat diet. Or I can think about drug and normal diet. Then I can have drug with high fat diet. So 4 combinations I can think about actually, correct? So that way we will know effect of diet on, effect of drug on diet, okay? And no drug with diet and drug with diet actually. So we can learn much more. So by doing 4 experiments, we have no drug normal diet, no drug high fat diet, then drug normal diet, and drug with high fat diet. We can study the interaction between drug and diet. Does drug have an effect when you take a high fat diet, or drug does not have effect when you take high fat diet? So these type of things can be done, and this is called factorial experiment. So 2 different factors, drug, no drug, diet, no high fat diet. So 2 into 2 raised to the power 2, that is 4 actually. Okay, these are called factorial design. And this is more efficient than giving no drug with 1 factor at a time, and look at no drug and drug, or normal diet and high fat diet actually. Okay, we can also study interaction. Suppose I have temperature and pH, looking at product yield. So at this pH, when I change this temperature, the product yield goes up, and at this pH 4, when I change the temperature, the product yield can go up like this. So you can have different types of graphs. There are graphs which look parallel, or graphs which seem to interact with each other. Okay, so that means there is no interaction between pH and temperature. Whereas if you see this type of graphs, you can say there is an interaction between pH versus temperature. Okay, with 2 parameters, it's easy to draw graphs, but with multiple parameters, we have to use software to see interactions actually. Because in many situations in bioprocess and chemical process, always there will be some effect of pH when temperature is at some degree, effect of pH when temperature is at some other degree. Even drugs also work differently on males when compared to on female. There are many drugs. Even certain drugs like anti-malarial drugs work differently with Asian population when compared to, say, European population. So that's called interaction effect. So we can study these type of interaction effects when we do a factorial type of design actually, because in real life always there is interactions. Okay. So a good experiment should be unbiased. Always do randomization and blind. You might have heard when we do drug testing, there is something called double blind. That means the doctor also should not know whether the doctor is giving a placebo or a drug. Patient also will not know whether he is getting a drug or a placebo. That's called double blind test. So that but completely bias is removed. Okay. Replicate. You have to always do many experiments to know the uncertainty. In a lab, we can do replicate. I can do at same pH 3 times, 4 times, but sometimes it becomes very difficult in real life. In industry, it may be difficult. Even when I'm doing clinical trials also, it may be difficult. But always lab experiments, always replication. High precision, same material, replicate, stratification. These are very important. It should also be for wide range of applicability. That's important. I cannot say my design is good for only 30 to 40 degrees, but it's not good for 40 to 50 degrees. So a little bit of range of applicability is also very important. And it should be simple. I must have simple experimental strategy to collect all the data and so on actually. Okay. These are the characteristic of good experimental design. So how do you determine parameters? We can think about as a scientist in a chemical lab, you may say temperature may have effect on yield, pH may have effect, pressure may have effect, concentration may have effect, and so on yield. So you always have domain knowledge. As a biotechnologist, I may say pH will have effect, maybe amount of bacteria injected may have effect, temperature might not have effect, and so on. Okay, whereas then if you're doing some experiments on mechanical engineering, as a mechanical engineer, you may have some already some knowledge of which parameters are important to study the yield or productivity or impurity level and so on. Okay, if you do not have expertise, you can have a team of people who have expertise in various aspects, and they can sit together and come up with parameters which are important to study actually. You can even select large number of parameters. That's called screening design. And then you do little experiment, and from there you find out some parameters do not have effect, some have effect. So you can eliminate some parameters which do not have effect and select only those who have effect and do a detailed design. So you can have a screening design, then you can have a detailed design. Both are possible. In screening design, you select a lot of parameters, then identify those which are very important, those which are not important, remove those which are not important. So focus on those, and then you can do a detailed design. So initially I may take 10 parameters in screening design, and then finally I see only 3 are very important from the results, and then take those 3 and you can do a very detailed design actually. How do you eliminate parameters? You can use statistical techniques. There are T tests are there, ANOVAs are there, which can say some parameters are very important, some parameters are not, and then only focus on those. In this picture, I am trying to show you delivery of say pizza. A delivery boy is delivering pizza, and time is a very important parameter in delivery. You might have, you all know actually in Sugi and so on. Time is a very important parameters, and there could be many factors which may be affecting time. What is the speed, what vehicle the person is taking, what is the speed of the vehicle, how efficient it is, okay, how experienced he is in delivery, what is the route he is taking in delivery. So these are some X's which he may be considering to consider the delivery time actually. So some parameters may be important, some may not be important. Okay, and some parameters you can't control. For example, environmental condition in some of the bacterial fermentation, the environmental humidity may have some effect, and so on. Some environmental factors may have effect which you might not be able to control. There are some variables which you may be able to control. We call it controlled variable. Some variables which you cannot control, uncontrolled variables, like I said, the humidity in the atmosphere, you might not be able to control. Okay, and so on actually. And so uncontrollable variables, at least you should know what variables I will not be able to control, whether they have very significant effect on my results. If they are going to have significant effect on my results, then I need to make it a controlled variable. For example, if I find humidity, which is a uncontrolled variable or ambient temperature variable, but it is going to have a major effect, then I may have to do all my experiments in a very controlled environment where the humidity is controlled. Okay, so we need to identify which variables are important, which are not important, which I can control, which I cannot control. Okay. So like I said, there are 2 types I need to plan: screening design and detailed design. In screening design, I can consider many factors. I can get the results, and then using some statistical tools like significance of the variable or T test, I can identify which variables are very important, which variables are not important. Then I can eliminate those variables, and I select only a small number of variables. Then I do a detailed design. So screening design, detailed design. Detailed design could be a second order design. Then later on, I can do a regression analysis and try to get a mathematical equation between variables and my results. Results could be yield of my product. Okay. So screening design, I take up only many factors, but I try to do as minimum experiments as possible. As you know, experiments take time. Experiment costs money. Experiments, I have to use a lot of chemicals, consumables. So experiments as minimum as possible, but getting as much information as possible. So screening designs are used for that. Then you can do a very detailed design and get a regression relationship with those few number of parameters. Okay. And then I need to decide which region I am studying. Actually, for example, you know, pH in a biochemical process will always be an optimum. If a bacteria is growing well at say 6.5 pH, if the pH is very, very acidic or very, very basic, the yield will be low. So we have certain operable operating region for pH. Again, in chemical process, temperature can be very, very wide range, but in biochemical process, if the temperature is higher, bacteria might not survive. Okay, so again, there could be some region of operability. That's called region of operability. Okay, so if I am studying car speed as one of the parameter, again, I might not be able to go up very high in the speed of the car, maybe in the roads, in our city roads. So again, there is an upper limit. So these are called a region of operability. So within that only we can work. We can't work beyond those regions. Actually, that's very, very important. So some parameters, like I said, are key factors which I can control: temperature, pressure, pH, amount of catalyst you are adding, or speed of an instrument. All those are controllable. There are certain variables which I cannot control. Those variables are very, very difficult to control, like humidity of the environment, temperature of the environment. I will not be able to control. So they are becoming a noise variable or uncontrollable variables. Okay. Generally, everybody thinks that one factor variation as a time at a time is good. That means if I am studying only temperature, I will change temperature 30, 35, 40, 45, 50, and so on, and study the yield. Then I will go to pH. I'll change 3.5, 4, 4.5. So that's called one factor at a time. This is a very, very wrong design. That means varying only one factor, keeping everything else common. That's called one factor at a time. That's a very wrong design, because we will not know what are the interactions. What are the interactions if temperature and pH are going to interact with each other? At certain temperature, the pH effect will be different, and certain other temperature pH will be different. Will I be able to study interactions? No. One factor at a time, you will not be able to do interaction effect. That is why we need to go for these factorial type of designs, which where you are changing many factors to achieve the interaction effect. So one factor at a time designs are not at all good. So factorial designs are very good. So imagine I have two factors, A, B, like temperature and pH at two levels. Two levels means temperature could be 30 degrees or 40 degrees, two levels. pH could be 5.5 or 6.5, two levels. So two factors, A and B, that is temperature and pH, two levels, temperature 30 and 40 degrees, pH say 5.5 and 6.5, two levels, two factors. I can do temperature at a lower level, pH at lower level. That means the temperature could be 30 degrees, pH of 5.5. Temperature could be high level, that is at 40 degrees, pH at 5.5 low level, or temperature at lower level 30 degrees, pH at higher level say 6.5, and temperature at higher level, that means 40 degrees, pH at higher level, that means 6.5. So four different combinations come in: low, low, high, low, low, high, high, high. So you understand. So two factors, two levels, 2 raised to the power 2, 4 experiments, 2 into 2, right? So we have low, low, high, low. So my 4 experiments will be, like I said, low means temperature at say 30 degrees, high means temperature at 40 degrees, and low pH means 5.5 and 6.5. Four combination of low LL, LH, LH, high HL and HH. So I have to do 4 experiments. So as you can see, I am changing both the variables nicely, both the variables at 2 different levels nicely. So I will be doing 2 raised to the power 2 experiments, that is 4 experiments, which is called a factorial design. So we can have factorial designs for many A, B, C factors, factorial design for level 2, level 3, that means temperature say 40 degrees, 50 degrees, 60 degrees. So all are possible actually. Okay, for example, I said time and temperature here instead of pH. So imagine 2 variables, 2 factors, time and temperature, 2 levels, time at 80 minutes and 90 minutes, temperature at 170 degrees centigrade and 180 degrees centigrade. So low, low, high, low, low, high, high, high. So obviously 80, 170, 90, 170, 80, 180, 90, 180. So I've done 4 experiments. You can see this. I have done 4 experiments, 2 factors, each factor at 2 level, 2 raised to the power 2. I'm getting some results. Say yield of a product, which is Y. Yield Y or dependent variable response. People give different names for this. Y dependent variable response, whereas here it is called X's, factors, independent variables. All these are various names actually. So I get 4 results. So I can see effect of time. The effect of time means here I have done 80, 80. Here I have done 90, 90. So add these two, 46.2 and 79.5 divided by 2, average minus 58.2 and 47.7 divided by 2. Sorry, 58.3, 47.7 divided by 4. So effect of time is the yield increases by 9.85. Effect of temperature, these two is low temperature, these two is high temperature, 68.3, okay, plus, sorry, 58.3 plus 46.2 by 2, 47.7 plus 79.5 by 2. So effect of temperature is 11.35. So when the temperature is increased, we see an increase of 11.3 in the yield. When the time is increased, we see an effect of an increase in the yield by 9.6. We can even see effect of time and temperature, that is interaction. I will show you a next example of that, effect of time and interaction. Also, whereas in one factor at a time study, we will not be able to do that sort of study actually. Okay, so this is once again 2 variables, 2 levels, so 2 raised to the power 2, 4 experiments I do, and that is called a factorial design. Now let us look at okay, 2 levels, 2. This is another way of representing that. Low level we represent as -1, high level we represent as +1. Okay, remember that. Another way is 1A, but we'll follow this. Low level is -1 plus high level is +1. So if you have 2 factors, 2 levels, -1, -1, that is low, low, +1, -1, that is high, low, -1, +1, that is low, high, +1, +1 is high, high. Okay, understand? So low, low, high, low, low, high, high, high. Exactly what I mentioned here, which is represented in a mathematical way, -1 for low, +1 for high. Now, if I want to study interaction, quite simple, minus into minus, that is interaction between A and B. What I do is I multiply these two numbers. Minus minus becomes +1, plus minus becomes -1, minus plus becomes -1, plus plus becomes +1. In factorial experiments, one interesting thing that happens is the number of pluses will be equal to number of minuses. Okay, that's very, very important. Okay, you can see 2 pluses are there, 2 minuses are there, 2 minuses, 2 plus. Here also interaction, we see this and this plus, 2 pluses, 2 minus. Now let us go to 3 factor ABC. For example, temperature, pressure, pH. Temperature, pressure, pH. 3 factors, 2 levels. So we put 2 levels, and that will be coming here. 3 factors will be the exponent, 2 raised to the power 3. That means 8 rands. Okay, here it is 2 levels, 2 factors, 2 raised to the power 2, 4 rands. Okay, here it is 2 levels, 1 factor, so 2 raised to the power 1 is 2. So the exponent is the number of factors. This 2 here is the number of levels. Levels means temperature at 70 and 80. That's level actually. Okay, so if you look at 2 raised to the power 3, 3 factors, 2 levels, 2 raised to the power 3 is 2 into 2 into 2, 8 runs. So I have to do 8 runs. Okay, A, B, C are the factors. Like I said, temperature, pressure, pH, for example, A, B, C. So how do I write the design? Quite simple, minus 1, minus 1, minus 1, all different combinations of minus and plus. You will end up with 8 runs here. Okay. So I will do eight experiments. First experiment will be temperature, pressure, and pH could be low level. If the temperature low level is say 30 degrees, this will be 30 degrees. Say pressure is say 1 bar, and then pH could be 5.5. Okay, so all the low levels like that. I will be doing 8 experiments here actually. Understand? So the exponent will be the number of factors or number of x's or number of independent variables, and the 2 here represent the levels, that is low level and high level. So if we have 4 factors, I will raise 2 raised to the power 4, 2 into 2 into 2, 16 experiments, and so on actually. So there are softwares which will try to give you this factorial designs also, but this is how it works. This is the fundamental concept of this. So interactions we can study by multiplying A versus B to get AB, or if you want AC, A versus A into C. So this will be a multiplication of this column and this column, and BC, this will be a multiplication of these 2 columns. So here when you have 3 factors, you will also have ABC interaction. Is there an interaction between temperature, pH, and pressure? That is what the ABC interaction means. Generally, such interactions are very rare, but this type of AB type of interactions are very common actually. Okay, at one temperature, the pH effect may be different, whereas at another temperature, pH effect may be totally appearing different. That is what it means actually. Okay, these are called factorial designs. Actually, in factorial designs, like I said, number of minuses and number of pluses should be equal. So it is totally balanced. They are called balanced designs. Pluses and minuses are also equal actually. Okay. Drawback of factorial design. If I put a 2 raised to the power 4, 16 experiments, 2, 5, 32, 2 raised to the power 6, 64. So the number of experiments increases so much. So it becomes very difficult for us to do. So there are other types of approaches by which we can look at reducing the number of experiments. So there are different types of designs actually. Okay, there are fractional factorial designs. That means I can do less number of experiments to get the more same data. It is a factorial, but it's a fractional of that. That's called fractional factorial designs. We will look at that because factorial design, as you can see, the number of experiments will go up so much as we keep increasing the factors. Okay, so there is something called fractional factorial design, which we will look at actually. There are Plackett-Burman designs, fold-over Causal designs, Latin square designs, Taguchi two-level designs. All these are fractional factorial designs, which can help you to reduce the number of experiments and get the same knowledge actually, same idea about the process. And they are also called linear designs because we do it at 2 levels. When we do 2 levels, we can, as you know, when I have 2 points, I can only get a straight line. I can't get a quadratic. So I must do at least 3 levels then to get a non-linear design. So initially we do a screening design, which are 2 level. They are called the linear design, and there are different types of designs available. I don't have time to go through all these types of designs to understand different types of approaches to use it for screening purposes, which are called linear designs. Okay. Plackett-Burman design is another type, which is also very commonly used, which has very low number of experiments, which are generally good for screening purposes only. That means when I have large number of parameters, quickly I will eliminate parameters and I will focus only on a few parameters. That's called the screening designs. Plackett-Burman design is a very commonly used. Actually, there are software which can do that. Okay, for example, imagine in fractional design, in factorial design, how to make a fractional factorial. Imagine I have three factors, A, B, C, I showed you, and each one has 2 levels only. So 2 raised to the power 3 means only 8 experiments I'll do. So A will be low level -1, B will be +1, like that. No, there will be only 8 experiments. Now, I want to do 2 raised to the power 4 design. That means I have A, B, C, D, factor D, but I don't want to do 16 experiments. 2 raised to the power 4 is 16, right? I want to do it with only 8 experiments. Can I do that? There is one approach. So this ABC you convert into D. Okay. So A, B, C, D, 4 factors. Instead of doing 2 raised to the power 4, which is 16, I will be able to do only with 8 experiments, achieve the same idea. This is called half fractional factorial design. Instead of 2 raised to the power 4, I am doing it with only 8 experiments. Okay, this is called a fractional factorial design, half fractional factorial design of 2 raised to the power 4. Actually. And softwares all automatically give these type of designs actually. So 4 factors, if I want to do half, then A will be say temperature, pressure, pH, catalyst amount could be D actually. So instead of doing 2 raised to the power 4, which is 16 experiments, I will do half of 16 experiments. That means that is called half of 2 raised to the power 4. Okay, so there will be some interaction effects that will be coming into the picture. But generally fractional factorial designs are used for screening designs. So a little bit of information will be lost, but that doesn't matter actually. So this is called half of 2 raised to the power 4 design. As I said, 2 power 4 is 16, 2 into 2 into 2 into 2. So either we call it half 2 raised to the power 4 or 2 raised to the power 4 minus 1. So 4 minus 1 means 3, right? So it's 8 experiments. We are putting 4 to show there are 4 factors, but only doing 8 experiments. So this is called 2 raised to the power k minus q. If q is 1, that will be half fractional factorial. Q is 2, it is 1/4. K represents the number of factors. Understand? So exactly the same. The k represents number of factors. 4 factors. If I put 1, that means it's a half fractional factorial design of 4 variables. So this is how it is represented mathematically. 2 raised to the power k minus q. Q tells you what level of fraction you are doing, and k tells you how many factors we are looking at. K could be 3 factors like temperature, pressure, pH, or k could be 4 factors. It could be temperature, pressure, pH, and catalyst amount. Okay, so if q is 2, that means I am doing 1/4 design of that actually. But in fractional factorial designs, we are able to do less number of experiments, but you will lose some information also actually. That's how it is actually. So there are many types of design. For example, 2 raised to the power 6. 2 raised to the power 6 means 6 factors. That means 2 into 2, 4, 8, 16, 32, 64 experiments. So instead of 64 experiments, this 2 represents level, right? I mean the reduction, that is 1/4. So instead of 64 experiments, I'm doing only 16 experiments. So 6 variables, x1, x2, x3, x4, x5, x6 variables. But I am doing only 16 experiments. That means 1/4 of 64 is 16. So this is a design which tells you for 6 variables, I want to do only 16 experiments. and this gives you the design. So minus means low level, plus means higher level. So x1, x2, x3, x4. Okay, you can see, and this will be x6 and this will be x5. So instead of doing 64 experiments, I have done 1/4 of 64, which is 16 experiments. Okay, understand? So you can have different combinations. So x5 will be here, x6 will be here, x1 is this, x2 is this, x3 is this, x4 is this. So, but you will be losing some knowledge when you are not doing the complete 64 experiments, but you are doing only less experiments. That's called confounding. So now some knowledge is lost, which is called confounding. Some interactions get mixed up. But when you are doing screening design, that doesn't matter. Okay, when you're doing screening design. So when I'm doing full factorial, like I said, 2 will be 2 raised to the power 1 is 2, 2 raised to the power 3 will be 3, 2 raised to the power 4. Okay. But instead of that, we are looking at some sort of a, fractional designs where the number of experiments reduce, and you are able to do the same number of knowledge generation with the less number of experiments. Okay, that is what is called a fractional factorial design. Okay, so again, I show you the same thing. So instead of 8 experiments, 2 raised to the power 3, you are doing half of, you can do half of 2 raised to the power 4. That means instead of 16 experiments and 4 variables A, B, C, D, you are doing 2 raised to the power 4 minus 3. I mean, sorry, 2 raised to the power 4 minus 1, which is 8 experiments only. Okay, so 2 raised to the power 4 minus 1, that is 8 experiments only you are doing, but you are able to look for 4 different variables. It could be temperature, pressure, pH, and say catalyst amount actually. So different types of designs are available for looking at parameters, but all at 2 levels. We are looking at linear designs. That's why we are having all at 2 levels actually. Okay. So these are different types of design. 2 raised to the power 4 minus 1 means 8 runs. 2 raised to the 5 minus 1 means 16 runs. You can even, this is half of 2 raised to the power 5. You can even do 1/4 of 2 raised to the power 5. That is why this 2 has come here. That means 8 experiments. But when you do 8 experiments, this is called resolution 3. And when you are doing 16 experiments, half of 32 experiments, this is called resolution 5. And when you are doing 4 minus 1, that is 8 experiments, this is called resolution 4. So you have different resolutions, and so the accuracy of the conclusion also is better. Generally, it is suggested that we should have look for resolution 4 or resolution 5 designs. Never go for resolution 3 designs actually. Okay. So different types of a number of experiments come into the picture depending upon the number of parameters. This is a very useful table to have. So 4 parameters, 5 parameters, 6 parameters, 7 parameters, and so on actually. And either we can do half of 2 raised to the power 5 design, or half of 2 raised to the power 4 design, or even 1/4 of 2 raised to the power 5 design. But the resolution becomes poor, and you can have half of 2 raised to the power 6. So half of 64 is 32 experiments, or 1/4 of 32 experiments is and so on actually. Okay. Okay. So imagine a simple system. Okay, so I have I have 3 parameters A, B, C, like a temperature, pressure, and pH. Okay, so I have done a 2 raised to the power 3 experiments, that means 8 experiments, A at a lower level, minus means lower level, B at lower level, C at lower level. This is the first experiment. I get some yield value. Okay, then I change A at lower level, B at lower level, C at higher level. I get some yield value. Like that, I do these 8 experiments. I get different values for yield. Then I can look at effect of each of these parameters. What is the effect of A? I will select these 3 experiments of A at lower level, sorry, these 4 experiment at A at lower level, these 4 experiment at A at higher level. So I will take Y5, Y6, Y7, Y8 divided by 4, then Y minus Y1, Y2, Y3, Y4 divided by 4. That will give you effect of A. And then effect of B, I will take all the minus here, Y1, Y2, Y5, Y6, and I will take a Y3, Y4, which are plus, and then Y7, Y8 are plus, and then divide by 4. Okay, so this minus this will give you effect of B. And similarly for C also, I will take all the minus for C here, Y1, Y3, Y5, Y7 divided by 4, and all the pluses for C is this, and this. I put it here, divide by 4. So I will know what is the effect of temperature, what is the effect of say pressure, and what is the effect of pH. Okay. Now, how do I get interaction between temperature and pressure, or interaction between temperature and pH? Okay, so I again go back to the same table. Okay, I again go back to the same table. So if I want to see effect of A versus B, so you can see here, these are the 4 minuses, minus. So the Y3, Y4, Y5, Y6 will come here, and Y1, Y2, Y7, Y8 are pluses. I put it here and divide by 4. Okay, again, effect of AC will be this column. That is A into C is this column. Effect of BC is this into this column, BC. Okay, so I will get for AC this plus, this plus, this plus, and this plus here, and then this minus, this minus, this minus, this minus here. So by taking appropriate pluses, column pluses, and taking appropriate minuses, I can see effect of AB, effect of AC, and effect of BC also. Okay, that means effect of temperature with the pressure, effect of temperature with pH also. So here I get the effect of main effects. The A, B, C are called main effects, and A, B, A, C, and B, C are called the interaction effect. Okay. So look at this problem. 3 effects: carbon concentration, nitrogen concentration, reaction time on my process yield. So you can see this is the process yield. I can put that same problem into this table, and I can get the effect of each of this parameter. Okay. So I will know effect of A, effect of B, effect of C by putting these numbers. Okay, and then effect of AB, effect of AC, and effect of BC actually. Now there is another design that's called Plackett-Burman Design also, which is also good for looking at screening designs. There are designs called fold-over Causal Design. This is a simple table for A, B, C, D with 10 experiments. Again, fold-over design matrix for A, B, C, D. Then there is something called Latin square design for a factor A, B, C. So many designs are there. Then there is a Taguchi design. Taguchi, no, you can note down this particular website. It gives you for different types of parameters and different designs: 2 parameter, 3 parameter, 4 parameter, 6 parameters, and different levels. All the designs are available for Taguchi. Like I said, softwares are also there, but if you want to do it yourself, these designs are available in literature actually. These are Taguchi designs. L4 design, that means 4 experiments, how to do experiments. L8 design, that means with 8 experiments, how to do the design, and so on actually. 9 experiments, 12 experiments, these are all 16 experiments. These are all Taguchi design. That is 11 parameters, 16 experiments, and these are called Taguchi design. So many types of designs are there. Then you have second order designs. That means instead of 2 parameters, sorry, in 2 levels. 2 levels is like 30 degrees and 40 degrees. So 2 levels. If I want to look at 30 degrees, 40 degrees, 50 degrees, that is second order designs. We can get even nonlinear relationship. Then there are central composite designs, which can do this type of second order designs actually. And there are Box-Benken design. Okay. Then 3-level design, just like 2 raised to the power n, you can also have 3 raised to the power n designs. So different types of second order designs are there, which can help you to look at variables, whatever number of n variables at 3 levels, just like at 2 levels actually. These are all called second order designs. One is called, and this is called the central composite design. Okay. And this is called the Box-Benken design. Okay. So these are different approaches there for developing your design matrix for both 3 levels, and they are called second order designs. So the advantage of second order, we can develop a non-linear relationship, mathematical relationship, because you have data at many points. You will have data at 30 degrees, 40 degrees, 50. So we can develop a quadratic relation. Whereas if you have data only at 2 levels, 30 and 40, we can develop only a straight line type of relationship. That is the disadvantage. But the 2-level designs, we do less number of experiments, we get more knowledge. There are different types of 2-level designs, like I showed you, Causal Designs, Taguchi Designs, okay, then Box-Benken designs, Factorial Designs, fold-over designs, okay, and then second order we have the central composite designs, the Box-Benken design, 3-level designs, and so on actually. Okay, this is called a Box-Benken design. In 3-level designs, second order designs, just like plus and minus, we also have 0. 0 is the middle point. So plus point is above the 0, minus point is below the 0, and 0 is the middle point actually. So this could be the middle point, and this could be the plus point. So if you take a cube, 3 factors a, b, c, the plus point will be plus to the 0, minus point is minus to the 0. So 0 is, it's not 0 levels, but it is at the central level. So the central point, 0 is always the central point. So if I have levels at, suppose I am looking at 30, 40, 50 degrees centigrade, I can call 40 degrees as my 0 point, and 30 degrees as minus point, and 50 degrees as the plus point. Understand? So if pH I have working at 5, 6, 7 pH, 6 could be my central point, and 5 could be my minus point, and 7 could be my plus point. Okay, so that is only a representation. Okay, so 0 doesn't mean do everything at 0 numbers actually. Okay, so there are many designs for the second order, the Box-Benken design, the central composite design, and the 3-level designs, which can do develop the experimental strategy for you. Okay, these are Box-Benken designs that is called, again, as I said, 0 means the central point, plus means the plus point, minus means the point below that central point. And there are different the statistics coming into the picture. I will not go into that. So summary of 3-level designs are Box-Benken design, full 3-level full factorial design. Again, you can have fractional factorial 3-level, and the Box-Benken design. And ultimately, once you have the designs produced, you have to use the data analysis tools, the Anova, the T test, F test, chi-square test. We can use regression techniques to develop, to see which variables are very, very important, which variables are not important, and then develop a regression relation between variables which are important. It could be a linear regression equation. It could be a non-linear regression equation. Okay. With second order designs, we can develop a quadratic type of relationship. And you use those equations for further prediction, for optimization studies, and so on. So in optimization studies, we use this type of mathematical relationship actually. So let me stop with this. As I said, the design of experiments is a very big area. It requires several hours. I have just given you a brief summary of both the linear designs and non-linear designs, that is two-level designs and three-level designs, that means quadratic designs and linear designs. Okay. Softwares nowadays give all these type of design details actually, so it's quite simple, which can do the job for you. So with that, we will conclude. Thank you very much for your time.
Thank you very much, Professor, for elaborating on the experimental designs. Students, if you have any queries or clarifications, you can ask Professor.
In fact, there are many softwares, Design Easy, Design Expert, all these softwares can design the various based on strategy you want to adopt actually. But what I have talked about gives you a fundamental understanding of how these designs are created.
Any queries, clarifications needed, students? I guess no.
Okay.
Okay. Thank you for your valuable time, Professor.
Thank you very much. Thanks.
Thanks.
Thank you, everybody. You can always get in touch with me if you are planning to do any designs and if you have any doubts on these designs. I'll be definitely pleased to answer all those questions. Thank you,
Professor.
Thank you. Thank you very much.
Okay. Professor Sindhumo.
Yes, sir.
Good afternoon, Professor. Good afternoon.
Good afternoon, everybody.
Students, next session we are having Professor Sindhumo from Department of Statistics, University of Madras with us. Okay. She will be giving a talk on small sample size statistics, which is going to be helpful for many of you as you are working in biological and microbial areas. Okay. So let's welcome Doctor. So, Doctor, you can start.
Thank you. Is my screen visible to you?
Yes, Doctor.
Okay. Yeah, the size is okay.
Maybe you can go full screen also.
Full screen options.
It's perfect.
Okay. First of all, I would like to thank this BIIS online school, the Birak Honeybee Network, for choosing me to present something on statistics related things that to the students enrolled in the BIIS school. The topic you gave is a small sample size statistics. I observed that the students are from biological background, if I'm right.
Yes, Doctor. Mostly from science background.
Okay. then I can tell you from which book which is suitable to you, that from where you can read these things.
You can share the details later, the email and also the PPT, then we will give it to the students. That will
Okay,
be,
sure. Sure. Oh, the screen. Yeah. So the small sample statistics is the topic. I think I would like to ask this question: do we need always small samples, or in which situation you can go for all small samples, or where we are okay, we don't have any other choice, but we have to restrict ourselves with the small samples. So before going to tell about small samples, I would say what is a sample and what is meant by a sample. The students may have a background of statistics or mathematics. I hope at least a mathematics background. So anyway, I will ensure that I am not going to give you much statistics or much mathematics. Everything I will try to explain in words. So population is a collection of objects that show some common observable characteristics. And though population may have many characteristics, okay. The researcher may be interested on particular characteristics, and probably they want to study on that particular matter. So, for example, you can even say the a population can be the people having affected by coronavirus, okay, in the country. That itself is a population, you can say. Or people who are vaccinated also, okay, that we can say as a population. Or the students who enroll in a particular university in a particular year. Or okay, you can even say the people who are affected by Delta variation of coronavirus. Like that, you can think any area you can connect with this. So when you are looking at a sample, okay, so what is the need of a sample, okay? Because see, by looking at this sort of population itself, okay, if you want to study something related to the population may be very big, vast in size. It may be bigger in size. So we need a representative of that population, and that is called sample. And when you are looking at the representative, and when you call it a sample, okay, it should be handy, okay, it would be able to either manually we could able to handle, or at least with the help of a computer we could able to handle the situation. Okay, that much size only we are looking at. And moreover, okay, when you go for a larger sample, what happened, okay, it takes time to collect samples, observations sometimes, and sometimes collecting sample itself is costly. And moreover, okay, when you are dealing so many items, okay, it's quite natural. We human, we all will do errors. So human errors, sampling errors, so many other technical errors, so many things can happen there. So that is why, okay, sometimes, okay, certain situation people love to go for small samples. And when you are choosing a sample, okay, in order to show that the sample is a representative to population, the sampling procedure, that means the selection of samples should be very efficient, and there should be an appropriate way to draw a sample, so that we should get a meaningful inference from the population. So let us say what are the factors influencing a sample size. Okay, so we would like to go for more information about the population. So it is hard to tell that more the sample size, more you will be getting information about the population, then you will be having more clear inference about the population. Of course, that nobody can deny it. And when you go for a smaller sample, okay, sometimes the samples, especially in the medical field, sometimes, okay, you may not be getting a very good sample. So if it is a rare disease and all, okay, we can't get a bigger sample. then you are restricted with those items. Say even a rare species of a plant like that. Okay, then what is available only we have to look at. So there may be a small sample is very much relevant sometimes. Okay. Whatever it is, sample is used for sample is used to get inference about the population. How can we choose a sample size? Okay, nowadays it is easy to choose sample size because there are so many sample size calculators are there. You can think about such things. You can so many things you can see in the computer if you search also. And from what basis they are giving such things? By if you just give a rough sample population size, and then you will be asked to give a quantity of precision, then the sample size calculator will be giving you size of the sample. Okay. So what is the precision? Okay, you have to have an idea about precision. Precision is the closeness of two or more measurements in each other. That is by definition. Okay. So it will be definitely different from accuracy. So precision for a given precision, you will be finding the sample size. That is the usual procedure. And other, if you are looking at the representative, the sample should be a representative of the population. Then it will be very much good. Okay, when you are go for a random sampling. Though people are sometimes people are go for system like a convenient sample also. The convenient sample, okay, if you look at sometimes if you apply some statistical tools, it may not be giving what the result what you are expecting. But certain situation is you have to go for convenient sampling. Then say for example, if you are going to do a sample like criminals who did serial killer criminals. So that means okay, you have to choose. Okay, you can't do a random sampling there because who are all accepted to face the interview only will be you can talk to them. Such a case, okay. If you are going for that sort of convenient sampling, case studies are okay, but statistical inference sometimes okay may not be you may not be getting a good results. So that is why people always prefer to go for some random sampling procedures. Okay, there are so many random sampling procedures. Okay, you can see n number of sampling procedures, but most widely used and very simple for undergraduate level students can understand. It's a simple random sample. So randomness, how can you make a randomness there? Okay, though people say randomness is the nature. Okay, the nature itself is having a randomness. Okay, how can you choose systematically and ensure that it is a random sampling? There is a mechanism available for that. People already people have developed a random sample table, so you can choose. Say for example, if you have 100 say 500 observations are there, that we called as 500 patients enrolled in a particular hospital, and that is your population size. Now you can even go for you want to take a random sample that okay, you can use a random number table, and the random numbers are available even in the calculator also. And random number generating things are already available in the even in the website. If you go for a Google search also, you can get it. The numbers come randomly, so that say first number may be 4, the next number may be 10, then other number may be say 72. Like that, 2 digits or 1 digits you can choose. So what is the number comes? Okay, you will be choosing that particular person from the list. So that is a style of a random sampling. Okay, how can you do a random sampling? That is also systematic procedures are available in the literature. You can follow it. And the other thing, the other interesting word in the title is statistic. Okay, sir has introduced me as a person from the Department of Statistics. And I'm talking about statistic, which is something different. Okay, meaning So I have removed the last alphabet S, and then I call it as statistic. So that is a technical term. So statistic is a technical term. What is meant by statistics? Say for example, if you have a population, you are collecting sample from that population, and then you have a, say for example, or 20 observations are there, and we call it as they are sample, and they represents my population. I have numerical values of those things, and I can do any mathematical function apply. Say for example, I can find say if I call for just for a convenient all the numerical observations I am naming as x1, x2, etc., xn. So they are numbers. I can take an x square, I can take, or maybe x plus some 5, like that. So any mathematical function of the sample observations is called statistic. So that means you can make n number of statistic. Then what is the relevance of statistic in our interesting field? This statistic, that means a certain type of statistic are used to estimate the population parameter. So if a statistic is used to for the purpose of estimation, they have a pet name. What is that pet name? It is called estimator. So estimator is nothing but a statistic, a function of the sample observation only. But they are widely used for estimating parameter of the population. So when you say parameter of the population, what is it? The population mean, the population variance. Like that, if you say they are parameters of the populations. Okay. So value of these statistics, because I have collected some numerical observations in my hand, and okay, say I want to take say 25 observations in my hand. If I am asked to find an average of it, you know that you have to add all the 25 observations and divide by 25. Yes, for a simple mathematics, I am getting average. Okay. So I was asked to, the question was, what is the population mean? But I have only sample in hand. So I can find the sample mean. And I say sample mean is a mathematical function. So it is a function of observation. So it is a statistic. But I have used that statistic to get an idea about the population mean. So that sample mean is an estimator. And I have calculated the value of that estimator by using the numerical observations in hand, and that numerical value is called estimate. So the estimate is the numerical value that I got from the sample, and that okay, I can call it as a population mean is estimated, or the sample mean is we can consider for the time being, because I don't know about the population mean. I can use time being the sample mean as an estimate for the population mean. So this is what the way statistics are used. There are so many statistics available for various purposes. Okay, and the simplest thing only I told you, sample mean. Okay, sample standard deviation you can use as a, or sample variance you can use as an estimator for population variance. Sample median, sample mode, range of a sample. So what are the mathematical functions, okay, which are useful for given an information about the population? That is fine. Okay, mean, trimmed mean, weighted mean, so many things you have studied. Range of a sample, variance. Okay, we can even say proportion of people having in a village. You can just look at a proportion of people vaccinated per household. We can look at. So proportion is also a sample estimate. Difference of two proportions. If you have two groups, difference of two sample means if you have two groups, or if you want to do some sort of standardization of the observation, that means you are subtracting the sample mean from every observation and dividing by sample standard deviation, you will be getting another mathematical function. That is another style of statistic. And we say if you do like that, we say it is standardizing the observation. That means the observation x minus its mean divided by standard deviation. So this this kind of exercise are useful for doing various statistical testing also. Okay. Now let us think about again. I have statistic in hand, and some of the statistic I have used for estimating the population parameter, and some are having that I called as estimators, and some of the estimators, okay, you can even expect good properties, right? So which are the good estimators? Because I have so many mathematical function I can think about. So which will be better? Then that means, okay, certain properties are available, and the estimators who are having certain properties, we call them okay, better estimators, like that. So commonly used one properties like that, unbiased estimators. There are so many properties: unbiasedness, sufficiency, efficiency, consistency. I mean the efficiency, efficiencies and all, consistency, all those things. You can even say they are large sample properties. So unbiasedness is it suits even for a small sample situation. So let us think about that particular property alone. So what is meant by unbiasedness? So unbiased means that the average of sample estimators over all possible samples, okay, then that will be equal to population parameter. So that means from the population you thought of taking all possible samples. For each sample you are taking average. Then so many averages are in hand. How many samples you have taken, that much averages are in hand. Take the average of those things, and then this property says that this average will be very much, it will be equal to the population mean. Mathematically speaking, it is known as expectation of the sample mean is equal to population mean. So expectation is a mathematical concept. So that means unbiasedness is a statistical property based on the probability theory. So because you may not have much background in probability theory, I'm not telling that much detail. And you can think about the relationship between the mean of all possible sample means and the population parameter. Okay. And this is a conceptual issue specified by central limit theorem that is coming under probability theory. So don't worry about it. Central limit theorem can applicable to many situations, but for that, probably you may be get a small background of probability theories. So I'm not going to going in details. But one thing I can tell you, central limit theorem helps. Okay, when you have certain things, when some statistic you have calculated based on the samples, and we were having small samples available. And okay, what will happen? The sample increases. Okay. Sample size increases. Okay, one sample size increases. What would be the nature? That is what it says. The central limit theorem says about. Okay, or those who have a mathematical background, I can tell you, say probability mass function, probability density function, like that. If you have probability theory concepts in hand, that means your population follows a particular distribution. The characteristics of the population which you are interested, okay, if that follows a particular distribution, and you know that it follows a probability mass function P of X, then you have the set of observations in hand, X into P of X. If you sum up for all the observations, you will be getting a mathematical expectation. Or the quality characteristics you observed in the population, if that follows a continuous density called as probability density function called f of x, because it is continuous, instead of summing up, you have to integrate. Then integral of x into f of x dx, that is a mathematical definition for the expectation. So that means probabilistically also you can think about, and mathematically also it's a proven technique. So expect sample mean, okay, when you are taking the averages of the all sample estimators, it be equal to population parameter. You can take this beautiful exam, this property. And simple data samples, okay, simple data sample cases, if you look at it, the sample mean is an unbiased estimator of the population mean, or even sample proportion. That's also an unbiased estimator of the population proportion. Then so that means sampling procedure also, okay, Okay, if you go for a comfortable sampling procedure also, then this unbiased property follows. Okay. The other thing I told you in the beginning, okay, if you want to fix a sample size, okay, there's a precision based sample size fixing is there. So what is a precision? Okay, precision, if you look at, so we have seen that a sample mean is a statistic, and we have used it for estimated purpose, all those things. So and you can think about so many sample means, okay, in a population. If you you can think about all possible samples in a population, you will be getting so many sample means. So when you change the sample means also, sample mean also changing. So that means sample mean itself is varying from sample to sample. So that means you can think about its variation. That variation you can assess using standard deviation. Standard deviation variance, if you are not studying, I tell you, the variance or the square root of the variance is called standard deviation. Okay. So if a statistic, which is estimator, okay, estimation purpose used statistic, and if you look at its standard deviation, it is called a standard error. Okay. This is considered for your precision. That means variation is smaller means you are close to the value. So the standard error is smaller, then you will be closer to the value. That means this standard error is used to assess the precision. Now, if you look at other things, sample size calculation, we can simply use on this concept. That means the connection of standard error and the mean statistic. You can think like this: standard error of a sample mean is the population standard deviation divided by square root of the sample size. So that means if you have an idea about the population standard deviation, you don't have an idea about sample mean or population mean. That is why we have used for sample mean and to estimate it. Then sample means standard deviation we called as standard error. So this connection between standard error and the sample size, the standard error is used for defining the precision. So this precision and square root of the sample size related formula you can use for getting sample size. That means n is equal to standard deviation sort of square is known as variance. So variance divided by standard error square, that you can use is a simple formula that you can use if you are fixing the precision. How can you fix the sample size? Okay. So in that case, okay, let us think a little more about, okay, the standard error depends upon the variability of the data in the sample and the number of samples in the experiment, such that for a given standard deviation, the standard error decreases as sample size increases. They are inversely proportionate. Okay. This means that a precise estimate of the population parameter is only obtained when sample size is large or when variability in the sample is small. So that is one kind of approach for thinking about or getting sample size. So the simple random sampling, I told you, the random sampling, I told you we can use a random sampling based on a random number tables are available, and you will be having a collection of numbers which are entirely random, and you can use those tables to think about connecting with your population units, pick up those units that become a part of your sample. Like that, you can make the sample as a random observation. Now, the simple random sampling is a procedure, okay, that we can take random sampling. And I told you so many samples, all possible samples in a population, and each sample can have sample mean, and you can take expected value of those sample means is a population mean. So how can you think about all possible samples? Okay, this gives you, the simple random sample gives you that an idea about around that. That means if you have a population of size capital N, component, I think you have studied in your too, okay, NCX, right? That combinatorial mathematics, right? NCN you have studied. So if you have a population size is capital N, sample size is small n, you can, how many possible samples you can take out of that is NCN ways you can think about it. So NCN samples are there. So NCN, say for example, if you have 10 observations are there, if you are taking 3 samples, 10C 3, like that. So 10C3 you can calculate. This is a simple mathematics you studied in +2. I think you all know it. So that means you will be getting to know the how many samples you can take from each sample. If you are giving equal chance to include, okay, if you want to take which sample you want to take, okay, you will be giving preference, equal preference to picking up of each sample, so that when you have the chances of selecting is equal, we call it a simple random sample. Okay. For selecting the random sample, already I told you, random number tables you can use, all those things. Okay. Now, this simple random sample itself, okay, so many versions are that you can take one sample and you can replace it like that, and that with replacement, without replacement, some 2 different way you can take. Most of the time, situation will be without replacement style will be more practical. There are other sampling methodology also. Just for your awareness, I am just telling another type of sampling procedure is systematic sampling. Okay. This is also a simple methodology that we can easily understand. Okay. That too, we can use your random number table also here. And all these things are, okay, when you have your population size is very small, then automatically the sample collected from the population is also will be small. Or you can say population size is finite, and you can think about all population units. Okay. Such all possible all population units, if you enlist them, it is called a sampling frame. So for example, people enrolled in a hospital on a particular day, or maybe in a week, like that you can think about. If you look at say for example 5,000 names you got in the hospital register, if somebody asks you to take a sample of size 30, and that is then all the 500 names list, okay, the complete list from the hospital register is known as sampling frame. Okay, so for systematic sampling we need a sampling frame, and you are going to pick up a point from that, or the person from that only. So you want to take 30 patients, so you want to get a random start among the 5,000 names. Okay, so you can use your random table to pick up a random number, and say for example that number was 7, so you'll be picking up the seventh person's name. You will be picking up from the sampling frame 500 among the 5,000 people. Then thereafter you will be skipping 30 names, and then you look for the person until you get 30 observations. You can keep doing all these things, and that will be a systematic way of picking up the samples, and you will be ensuring it as a random sample because you started with a random point. Another way of see, if you have larger number of observations, okay, some days you may not be going to think about the sampling frame. Okay, that case a sample can be say 1% of data, like that. That means your population is large, then you can't do this kind of exercise. Then you can another way of selecting, the simple way of selecting sample is, say for example 1% of the that means proportionate to your thing. So 1% of the total population I am considering as a sample, like that also you can fix it. So then okay, what can we do? Okay, if you know you got some idea about what's population, what's sample, and how to take sample, and if you have samples, okay, what you have to calculate from the sample, and what you have, that means you may be thinking about some estimators, and you will be getting inference about the parameter of the population based on those estimators. And then you want to know whether your calculated value is nearer to your population value or not. Okay, that means you have to go for some sort of framework that will ensure you that, okay, this you can say that, okay, what I am presenting from the sample, okay, based on the sample is, okay, statistically significant or not. Okay, that you can do. Okay, so there comes the testing statistical hypothesis procedures. Okay, so testing statistical hypothesis procedures, if you look at, that is, see, there are it's a systematic procedure to do a test, a statistical test with the help of certain statistic. Okay, those statistics may be calculated from small samples or maybe large samples. Okay, let us restrict ourselves, okay, the situations where small samples are used. Okay, so this testing hypothesis system has two types of hypotheses we can think about. Okay, one is, okay, so if you are an experienced person, okay, you may have some idea about your population, the population you are handling. Then that researcher's idea, okay, that means your guess, okay, based on that you have you can frame a hypothesis, that is your guess related to the population, and you want to check whether your guess is correct or not. Okay, so based on these two things, okay, there are two types of hypothesis. One is known as alternative hypothesis, the other is known as null hypothesis. So what is alternative hypothesis means? Normally the researcher's assumption which you want to cross check whether it is statistically correct or not, whether it is statistical inference is correct or not. Okay, that is we framed as alternative hypothesis. Okay, then your alternative hypothesis you want to cross check by using a methodology, and that for statistical methodology, for developing that procedure, you will have certain assumptions, okay, regarding to that one. So that theoretical assumptions, that is known as null hypothesis. Okay, so under the null hypothesis only procedure is developed, and based on that procedure you will be cross-checking, validating your estimator and whether it is nearer to your population's parameter or not. Okay, if after conducting the test, okay, based on the inference you are getting out of the test, you will be choosing whether your assumption is correct or correct or not. So, but what happened, the theory is developed based on null hypothesis. So what you do, whether you will be accepting the null hypothesis or rejecting the null hypothesis only you can say. So when you are rejecting the null hypothesis, then what means you have an alternative choice. What is that? Based on your experience, you have an understanding of your population. Then if you are rejecting the null hypothesis, then your alternative choice is correct. That means the researcher's choice is, you can go ahead with that. Okay, so this is that is why we are doing a statistical hypothesis. And there are different types of statistical hypothesis situations, we can say, based on what you are, what sort of things you are, characteristics you are of the population you want to check. Okay, based on that, that testing statistical hypothesis itself you can think about as two ways. Say it is known as parametric test and non-parametric test. Many parametric tests are also using small samples, and many non-parametric tests are also using small samples. How can you use all these things? Okay, if I am mathematically weak and I don't want to study statistics much, all these things, if I am happy with the playing with the computers, okay, then there are so many ready-made packages available, and where you can just feed the data and you can fix certain things, and the software will give you maybe a software manual or software how to use software if you know that. Okay, without much pain, you can get a result. Okay. So the Spss is one type of packages like that. Okay, this I told you that we have already gone through what is an alternative hypothesis and the null hypothesis. Okay, and now let us think about what is a non-parametric and hypothesis and parametric hypothesis. So I told you in the beginning, populations may have so many characteristics. Sometimes you may be you may have a guess that a population particular characteristics follows a particular distribution or not. If you have an assumption about that distribution, if then we will be using non-parametric test because you don't have actually what distribution it follows, but you have some by some preliminary studies. You can even say some histogram sort of thing, and okay, you can study. That is very simple concepts. Okay, by using you may get an idea. Okay, you have a guess that it follows a particular distribution. So I just want to cross check with the help of a testing procedure. So I'm not sure whether that distribution follows a particular distribution. My guess, I want to cross check. That time, okay, we can use a non-parametric test. Okay. Suppose you have more clear picture. I know that this because I am handling this population so many years. Okay, this follows a particular distribution. And say, for example, so many distributions. I don't know whether you are familiar with the probability distributions, binomial distribution, Poisson distribution, normal distribution, exponential distribution, like that. So many distributions are available. Probability, at least probably people are known, at least after the corona, people are known on the word exponential. Okay. Corona, people having affected corona is exponentially growing like that. Many pictures you might have seen in the newspapers. So that means that some distributions related matter you can apply for such a case also. So let us think about a widely used distribution called a normal distribution. A normal systematic distribution. So that means, for example, you have more idea about the population that it follows a particular distribution. Then you may not be knowing the populations, mean populations, variance. That distributions mean distributions parameter is going to be there. That means you know the distribution. Then you will be looking at the value of the parameters of the distribution. Then it becomes parametric hypothesis. Okay, let's think about some examples of hypothesis framing situation. So the number of corona cases in a state follows exponential distribution. That means people have an idea that follows exponential distribution. But the exponential distribution, its mathematical expression is lambda e power minus lambda x. So lambda is the parameter of that exponential distribution. But we may not be knowing the value of lambda. So that is known as parameter of the exponential distribution. Then if you want to have a guess on the parameter by collecting some samples, okay, and considering a suitable estimator, that case it is going to be a parameter test. Suppose there is an association between age and length of stay in a hospital for a respiratory disease, because we have seen that these kind of viruses are affecting respiratory system, and after affecting the respiratory system only nowadays government is allowing to hospitalize the patient itself. Okay, so the length of stay, people want to make it shorter because the one particular phase of the corona, if you all remember, the length of stay in a hospital, they are not allowing much time. They are asking people to go home and to do quarantine. So that means the length of stay in a hospital for a respiratory disease. Okay, and the people have studied that study also. You might have read from the newspapers. The people who are having aged people with some other complications, they were risky after affecting this virus. So that means their length of stay was larger. So you want to check whether there is an association between age and the length of stay. So that means you are looking at the association between two variables. Then that comes in a non-parametric study. So like that, the situations, okay, so many situations based on that for an experienced person can understand. Okay, parametric hypothesis or non-parametric hypothesis you can use. Okay, the situation. And that probably for a beginner it may be a little bit tough. Okay, but once you are familiar with these things, okay, you may be now into understanding, okay, which type of hypothesis you have to go in. And once you decided parametric or non-parametric, then your hypothesis, null hypothesis and alternative hypothesis are based on that will be varying. Okay, so this is what I was talking about. I think this page we can just skip. And certain type of measurements also will help you to decide, okay, which parametric or non-parametric test you have to take. Okay, so there are 4 types of measurement. Okay, like we can say is scaled, continuous scaled. That means, for example, length of height of a person is a continuous scale only. Okay, ranking scale will be there. Then interval scale, ratio scale, like that. How the variables are observed, okay, based on also the nature of the variable also will help you to decide, okay, parametric test or non-parametric test. Anyway, that's, I just want to give you an idea only. Okay. But the parametric test will have so many assumptions you have to cross check, but non-parametric test will not have much assumptions. So some of the assumptions for your understanding, I tell you, parametric test is, say for example, you have, there may be an assumed distribution exponentially following or normally following, like that. Variances are a homogeneous variance or ratio or interval data or independent relationship, or central measures you can find, mean, mode, median, like that. Okay, like that, some assumptions you can think about it. So non-parametric test you can think about, we may not have much idea about the distribution, any distribution, or there may not be an assumption about the distribution at all. Okay, like this. And median, if you look at mean and median, what is the difference? The mean is calculated based on all observations. Median is the middlemost number, so it's just an order only we are considering. Like that, okay. Moreover, ordinal scale variable you can do only non-parametric test. Like that, certain rules and relations are there to choose. Okay. Now I just have a 2 or 3 slides only. I'll explain, because it's already 2:30. Will not take much time. So just tell you decision-making measures in a test. Okay, that means we have to check certain things. One is the level of significance, people say, or the probability value, we say. So these 2 things are known as decision-making measures in a test. Okay, so that means level of significance means the probability of type 1 error we committed. That means type 1 error, if something is good, okay, but you say, unfortunately your sample you have taken, so for example, your population mean, you want to estimate, you have a sample mean, in fact it was closer to the population mean, because we don't know exactly, okay, but the real picture, the sample was taken in a different way. Because of my sample, I told you, sample to sample statistic value is varying. Sometimes the sample, because of the sample problem, sometimes, okay, we are, though we want to, though it was an acceptance matter, okay, we are, an inference of the test was, unfortunately you have to reject the test. So that means, okay, when it's something, sometimes such error can happen, and such things, okay, when something is correct, but the correct decision decision taken was not correct. Okay, in that case, we will, such a situation we want to avoid, but we cannot completely avoid. We can make its probability as a very, very minimal level. That means very rarely only a good situation or the correct situation we reject. Okay, so that, for that, with a very rarely you can make a numerical value. That is what if that is what it is fixed as 0.05, 0.01, 0.001. It shows very rarely only such a error will happen. ബാഗില് ഒരു പച്ച കളർ. I'm sorry. The other thing is known as probability value. So that probability value is based on this statistic which we are using. Statistic follows sometimes samples to sample statistic values different. So statistic can be a random variable. So that statistic will have a distribution, or the function of that statistic itself may be a non-distribution. Okay, and this probability value is decided based on the what statistic we are using to test. For the in the testing hypothesis, we will be using many statistics. I'll show you one or two examples. That statistics distribution is and this probability value fixed based on that one. Okay, so these two ways you can think about decision making principles they are. So what is the testing procedure? If you look at, you will be first you will be deciding whether actually what is the situation, whether it is a parametric test situation or a non-parametric situation. Okay, it is suppose for example it is a parametric test situation, and we are going to take a null hypothesis and alternative hypothesis. You know that alternative hypothesis, our assumption about the population, and null hypothesis, what sort of test you are going to choose. Okay, that procedure will have a style of null hypothesis. Then your size alpha, that the previous slide I told you, the decision making levels, we fixed a p-value or size of the test we will be fixing. Then you will be choosing a suitable statistic to do the test. Then that suitable statistics will be there will be a threshold, okay, for that particular value. Beyond that, if the value of the statistic goes, okay, we will be rejecting like that. So there is a acceptance rejection criteria for the hypothesis. And then suppose you are using a Spss or some packages, okay, you will be directly giving you the probability value. Probability value only I wrote here p-value. Okay. So some testing procedure which are using small samples. Okay, we were talking about, that means mean sample mean you can test. Okay, that is single mean test. When you have two populations, double mean tests are there. When you have, that means two means itself independent, two means, okay, dependent samples can be there, and more than two means, okay, you will be going for F test. F test probably you may be familiar with, because you might have already seen design of experiment. Anova test you might have seen. Okay, so Anova test you will be using a statistic in terms of variances, right? If you remember the previous talks, probably it may be belonging to such things. Non-parametric test normally say chi-square test, binomial test, run test, Kolmogorov test, independent sample test, like that. Okay, all these tests are using small samples statistic. So I told you what is the statistics, and okay, and what is the use of a statistic, and what and how can you use that thing for extending to testing procedure. And in the testing procedure, what kind of statistic you are using, or what is the testing procedure, what kind of a testing statistic we are using. For example, I am giving you, say, the one sample mean test for based on one sample. Okay, so if you look at this table, you can see so many functions. Okay, these functions are functions of samples or statistic, and this is, say, for example, the first one, z is equal to x bar minus mu divided by sigma by root n. That is a statistic we can use for testing the population. Mu is a population value. Population value is a particular number or not. If you want to test, you will be collecting sample, and you will be estimating sample mean x bar from the sample. So that x bar minus mu divided by sigma by root n is a statistic. Excuse me. Amma sattam podadama. Deepak, the class. So this x bar minus mu by sigma sigma into root n is a statistic which is used for testing mean test. Okay, population mean is equal to a particular value or not. That is divided into two cases, when the population standard deviation is known or population standard deviation is unknown. So the population standard deviation is unknown. You will be sigma will be replaced by S, sample standard deviation, and then sample size will be using small n minus 1. So that means it shows that again here sigma known, sigma unknown case. Okay, you have two different statistics, and the statistic is a sample function, and if you change sample to sample, it will also changes. Okay, so that is a random variable. So this statistic itself follows a particular distribution. So the first statistic is that x bar minus mu sigma by root n follows normal distribution. Okay, and the second statistics for the same purpose, for testing the sample mean. But what is the drawback here? You don't know what is the population standard deviation, so you are estimating it as S. So x bar minus mu divided by S into root of n minus 1. That is the statistic again used for testing the sample mean, testing the population mean. Null hypothesis will be mu is equal to mu not a particular value, and alternative hypothesis, okay, mu is equal to what is your guess, okay, like that. Or maybe mu greater than mu naught, mu less than mu naught. So that if you study the testing hypothesis part, you can explain all those things. So I'm just telling you there are two statistics for the same test we are using. The difference is sigma known and sigma unknown. But in the sigma known case, the statistic follows normal distribution. Sigma unknown case, when you are substituting sample standard deviation, there are two statistics involved here. One is sample mean x bar and other is sample standard deviation. So you can see a ratio of those things. So it is going to be an entirely different function. This follows students T distribution. So these names are distributions. If you are familiar only, you can understand. And the other thing is, okay, these two things are, okay, the first in the parameter test outline single mean test, double mean test, independent sample test, like that I gave. Okay, so those three things matter only I have given here, just to show that what is the statistic or which we can use in different situation. And these things are sample sizes are known to us, and the sample sizes are small also, the small samples. So what happened when sample size is larger? Okay, because if you look at, these are all something a statistic minus some sort of mean divided by some sort of standard deviation, like that, a standardized style. Okay, standardized style means I'll show you what is that standardized style. We have already met those things. Somewhere, I mean, yeah. You can see so this is equal to x minus mean by standard deviation. So that means the statistic minus its mean divided by its standard deviation style. That is known as standardizing the observation. If you are standardizing like that, okay, after that that variable will be when sample size is larger, it will be automatically whatever be the distribution, particular distribution that statistic follows. When the sample size is larger, it will be going. It will be end up with the that means it will be approximately normally distributed. So then whole procedure will be based on the information you are getting from the normal distribution. That means the statistic distribution will be normally distributed when you are increasing sample size larger. Okay, so that is why there is a small difference. People say small sample test and large sample test. Okay, but when this particular sample small sample statistic become large sample or maybe the normally distributed, if you look at see nowadays it is easily understand. Okay, if you just look at the value of that distribution, either you use students T or you use normal distribution, one particular sample size, okay, it crosses, okay, automatically the both value will be giving the same. Okay, so the numerical value of the probability of that statistic will be almost same. Okay, that is what approximately normally distributed. Okay, So this, okay, some, I think this I'll skip because this is okay. If you have some idea about the testing of hypothesis only, I can explain. I don't know about your background, so I'm just skipping all those things. So I just gave thought of sharing how can we use all these things in SPSS, okay. Other thing is, okay, other thing is, okay, there are other, I just want to show that, okay, there are other methods also to find out sample sizes, okay. That means in a particular test you want to do, but I have this much precision I estimated. So where this precision matter comes in the discussion we took, the precision matter comes, okay, in the what is there in the denominator, okay. So that in the denominator part will be always related to standard deviation, or the standard deviation of the statistics is known as standard error, okay. So the precision matter is based on that. So that means those statistics also you can use for a fixed standard error. How can you find samples? That sort of works are also available. That's also simple work only. You can easily understand. So I think because the time is over, I will close here. If there is any questions, you can ask.
Thank you, Doctor. Thank you for an elaborate lecture.
Thank you, sir.
Students, if you have any questions or clarifications needed, you can ask Professor. Any doubts?
Probably people are hungry and
continuously 4 lectures on biostatistics.
Yes. That's the because of that only I reduced many mathematics.
Any clarifications needed? You're tired. You can share the PPTs and some literatures for reading with us, Professor. We'll share with the students. And if any questions, we will get back to you.
Definitely.
Thank you so much, Professor, for your time.
Thank you, sir. Thank you, BIIS.
Okay. So we have come to end of the day's session. I have shared some details on the WhatsApp yesterday regarding the assignments and quiz programs for tomorrow. So please go through all these sessions, and questions for the quiz program will be based on all the lectures you have attended so far. Okay. So come prepared tomorrow. Thank you.